Everyone, welcome back to the channel. In today's video, we are going through an entire primary 6 PSLE preliminary paper from Nan Hua Primary School. This is for 2025. I will be solving every question step by step, explaining the methods, common mistakes to avoid, and how to approach tricky PSLE style problems efficiently. If you're preparing for the PSLE, or if your kids are preparing for PSLE, this video will help you understand the thinking process behind each solution, not just the final answer. So grab your paper, pause the video whenever you want to try the questions yourself, and let's work through the paper together. Let's start. This question is 800,014 in numerals is. So we see that the highest value is in this position, 100,000. So normally we would have, let's say the first one is ones place, tens, hundreds, thousands, 10,000s, and then 100,000. We can stop there. So it's going to be 1, 2, 3, 4, 5, 6, 6-digit number. So definitely these two are gone. So it's a question between these two. Now, 8 is the value that is in 100,000 position. So 800,000 means in the 100,000 position, I drop this 8 here. And what is left? 14. 14 we know has to come at the end because it's made of 1 tens and 4 ones. The remaining places we substitute with zeros. So the answer should be 800,014 is this. So this is your answer here. In the number line, what is the value represented by A? Now you see that this is 1 here and the next number here is 2. So the length of this whole the length of this is actually 2 minus 1, which is 1. And this 1 unit here, the length of 1 unit is divided into how many parts? 1, 2, 3, 4, 5, 6, 7, 8 parts, which means the length of each of these is 1 over 8. Similarly, the length of this will be 1 over 8, this will be 1 over 8, and so on. So now we already have 1 up to here. Now, if I want to go up to here, 1 plus how many 1/8s are there? 1, 2, 3, 4, 5, 6 1/8s are there. So actually from here to here, it's 1 plus 6 times 1 by 8. And simplifying 6 by 8 or 6 times 1 by 8, both are divisible by 2. So this becomes 3 and then 4. So this is equal to 1 plus 3 by 4. Now if you have worked with fractions and decimals, while looking at it, you know 3 by 4 is equal to 0.75. If not, you can divide 3 by 4 and check it out. 3 is smaller than 4, so you start with a dot, which means it allows you to add a 0 here. 4 7s 28. So remainder is 2. Since you already have a dot or a point here, you can add a 0, 1 0 here. So 4 5s 20, and so it is 0.75. So it's 1 plus 0.75, which is equal to 1.75. And the answer that you see here is this 1.750. Remember, 0 at the end of a number after the decimal point doesn't have a value here. So 1.75 is also equal to 1.750. So these two are equal, and this is the right answer. The next question is based on BODMAS, brackets, operands, division, multiplication, addition, and subtraction. This gives you the priority when you move from left to right. So in our case, there are no brackets, there are no operands, meaning there are no 2 to the power of 3 or 3 to the power of 2 and so on. So this is no longer there. Now what we have is division, multiplication, and addition here. So when you come from left to right, you always go from left to right. First pass, when you come here, there is a division. So, and that has higher priority over, sorry, there is an addition here, and then you have a division here. Division has higher priority over addition. If you look at it, division comes here. Division, multiplication has equal priority, and based on who comes first, we do that. Similarly, addition, subtraction has equal priority. Based on who comes first, when we come from left to right, we do that. But division, multiplication has higher priority over addition and subtraction. Here, division is here. So we have to do this first. When you come from left to right, when you compare this division and multiplication, both has equal priority. So we do this first. So it will be 12 plus 6 divided by 2 is 3 times 3. Now again, you have addition and multiplication. From left to right, when we come back again, multiplication has higher priority, so we do this first. So it would be 12 plus 3 times 3 is 9, which is equal to 21. So the answer should be 21. Which pair of lines in the square grid is parallel? Take a look at the first choice offered, AF and FE. AF and FE, they're definitely not parallel because parallel lines, they do not meet. They just go on forever without meeting. These two are meeting at F. So this is definitely not the case. Then AB and DC. AB and DC, they might be parallel, but how do we verify that? Now take a look at two things. One, AB, it goes from, like, it is actually kind of looking like a diagonal for this square, right? And here again, for the first part, it is a diagonal, and it is a diagonal for all these parts, so they should be parallel. There's another way of exactly saying if they are parallel or not. From A to B, how does it go from A to B? One point or 1 unit down and 1 unit to the right. So AB is 1 unit. Let me put a different symbol here. 1 unit goes down and 1 unit goes to the right. Now let's look at DC. We again go from the top. Don't go from the top for this and the bottom from this. Go from the top, from D to C. Let's say what happens from D to C. It goes 1, 2, 3 units down and 1, 2, 3 units to the right. Now, when you look at it, see, they are in a proportion 1:3 for the length of it. And if I do times 3 to it, I get this, which means they are going to be parallel. So this is definitely parallel. Now, which pair of lines is in the square grid is parallel? So we have found out, but still, let's just go through that and verify how we can cancel this. AF and BC. AF and BC. By looking at it, you know that they are not parallel, but just how do you verify? Let's say I move from A. AF can be written like this. From it goes 1, 2, 3 to the right, and from here 2 up. Now, when you look at BC, it goes 1, 2, 3, 4, 5. Is it 5? 1, 2, 3, 4, 5. Yes, 5 to the right. From B, I go 5 to the right and then 2 up. So now you look here. Are they proportional? No, because I cannot multiply. I mean, I can convert 3 to 5, but if I apply the same thing, this will not, because this is the same. So the slope is not equal. And if the slope is not equal, then they are not parallel. So this is definitely not parallel. And BC and CD, BC and CD, they are meeting at this point. So if they are meeting, then they are not parallel. So this is also not correct. I went through the rest of these options for you just to be more clear on how to identify if they are parallel or not. Now let's move on to the next question, number 5, which is AOB, POQ, and XOY are straight lines. Let me just show this. Let's say AOB, this is AOB, which is a straight line here. Let me use a different color here. And POQ is going to be a straight line like this. And let me see, XOY is like this. So these are 3 different straight lines here. Which of the following is true? And most likely there are no other information given. So we are going to talking about, like, if 2 lines cross each other. Remember, if this is AB and CD, for example, if these 2 lines cross each other, these 2 are vertically opposite angles. Similarly, these 2 are also vertically opposite angles and they are equal. Now, we are comparing DC, angle between AB and CD. That is what this is. Again, I'm comparing angle between AB and CD. That is this angle. That is when we tell them that they are vertically opposite angles. I cannot compare angles between different lines. Like, for example, if I had CD here, or let's say EF here, I cannot say okay, this angle and this angle are equal. I cannot say that because here I'm comparing between AB and EF. Whereas here, I'm comparing between AB and CD. That I should know. So that's what is going to happen here. Which of the following is true? Angle AOY, find this is the angle, and angle XOQ. See here. Here AOY means you're comparing angle between AB and XY, whereas XOQ means you're comparing between XY and PQ. The lines that you're comparing are not the same, so they are not equal. Similarly, XOB, this is comparing between XY and AB. This angle is between XY and AB. This is definitely equal to AOY, that is sure. But here, the other angle is angle YOQ. This is YOQ. Definitely not between the same lines, and also they don't really look to be vertically opposite. So this is wrong. And AOX, AOX. So this is between AB and XY. Let me just choose another color just to show that clearly. So AOX is here. So it's between AB and XY. And YOQ. YOQ is again here, the one that we shown here. Looks okay, but if you look at it, AOX is between lines AB and XY, whereas YOQ is between XY and PQ. They're not comparing between the same lines here, so they are definitely not okay. Then the last one, POY. POY is between which two lines? It is between PQ and XY. So POY. Let me say this is this guy. So POY. And angle is equal to angle XOQ. So this is and this angle, right? So this again is between XY and PQ. So between the same pair of lines, and they are vertically opposite as well. So this is the right answer here. The figure is made up of four identical right angle triangles in a square. What percentage of the figure is shaded? From my opinion, actually, this should have been four identical right angled, it should have been isosceles triangles. If that is there, then this makes perfect sense in solving this issue. Otherwise, we would not be able to solve this. Now, if these are identical triangles, we'll assume this to be shaded as well. It's not clearly seen here, but this is actually shaded. So we'll take that into account. And we see if these are identical triangles, this length here should be equal to the length here. Again, which means this and this should be of equal length. So this is half the length. And if I were to draw or mark the midpoints here and draw a line like this. Now remember, if these are isosceles triangles, then this length and this length is equal. So that is the key here. And if this is the case, then I know that if I draw a line, this length will be equal to this length, and this triangle, because this is made of 90 degrees here, right angle triangles, these two will be identical. And this triangle will be identical to this. Similarly, I can draw any line like this or like this, whichever way you draw. You can go ahead and draw, and these all will be identical triangles. And that happens only if I know that this length is equal to this length. So that's why I introduced this isosceles bird here. Now, once we do that, all these triangles that you see are identical. So in total, I have 1, 2, 3, 4, 5, 6, 6 on top, 6 below. So totally, I have 12 triangles here. And out of 12, how many are shaded? 1, 2, 3 are shaded. So 3 over 12. So that on simplification becomes 3 times 1, 3 times 4. So that is 1 by 4. And if I want to convert this into a fraction into percentage, what I do is times 100%. So that's how you convert a fraction into percentage. So 4 times 25 is 100. So the answer is 25 percentage. So the first option is the answer. The next question, the duration of a movie is 1 hour 40 minutes. The movie ends at 5:30 p.m. What time did the movie begin? Before you even go ahead and start, look at these options here. This is 5:30 p.m., which clearly means it's a 12-hour clock. But the answer is given here like 0350. There are no AM or PM, but it's 0350, 0710, 1550, 1910. So this is based on 24-hour clock. So a couple of options here. First, you can work using this time. And then when you get the answer, you can convert that into a 24-hour clock. Or you can do the other way also. You can convert this into 24-hour clock first and then start working on it. Let's do the first approach. That is, start with this to be 5:30 p.m. Now, the movie ended at 5:30 p.m. It started somewhere here, so we'll have to travel back in time. Now, we will have to travel back 1 hour and 40 minutes. So first, let me take 1 hour. So 1 hour prior to 5:30 would be 4:30. Now, I've accounted for this 1 hour here. So now I'm left with 40 minutes. Now, this 40 minutes, because I have a 30 here explicitly, I will divide it into two parts, 30 and 10. So first, let me go for the 30. Move 30 minutes previously or prior. So that would end up with 4 o'clock. And now, 1 hour before that will be 3 o'clock. And this is divided into how many minutes? 60 minutes actually. All right. So this is made up of 60 minutes. Now I'll have to travel back 10 minutes. So from here, if I travel back 10 minutes here, and this is 10 minutes, out of the total of 60 minus 10, that will be 50. So this is 50 minutes here. So that is 3 hours and 50 minutes here. So the time that we got is 3 hours and 50 minutes. And this is PM. So anytime you have PM, if you want to convert it into 24 hours clock, add 12 to it. So the answer would be 15:50 PM. So if you get an AM, you don't have to do anything to convert it into 24 hours clock. But if you have it in PM, add 12 to it. So you get the answer to be 15:50. So the answer should be 3. Arrange these distances from the longest to the shortest. These options are given in kilometers, and this one is in kilometers and meters. This is again kilometers. So one option we have is convert this into kilometers, this 40 meters into kilometers, and then try to compare, but even then this is in decimal. So another option is convert this fractional parts, the decimal parts into meters. For example, 1 kilometer is equal to 1,000 meters. So what is 1 by 4 kilometers? So 1 by 4 times 1,000. And this is 4 times 250. So this is equal to 250 meters. So 1 by 4 kilometer becomes 1 kilometer and 250 meters. Now look at here, this we can leave it as it is. This is 1 kilometer, 40 meters. Now 1.3 kilometers. So 1 kilometer again we saw is equal to 1,000 meters. So what about 0.3 kilometers? So this would be 0.3 times 1,000. And because there are 3 zeros here, what do? You move the decimal point 3 digits to the right. So let's say 0.3, you have to do it 1, 2, 3, which means you will have a 0 here and a 0 here. This point is over here. So this is equal to 300 meters. So this becomes 1 kilometer and 300 meters. So the longest is 1 kilometer, 300 meters, which is 1.3 kilometers. Look at the options all here. This is the only option that has that as the option there. And again, the second option is 1 kilometer, 250 meters, which is 1 by 4 kilometers. So that is given as the second option here, and followed by 1 kilometer, 40 meters. That is the third option here. So this is the right choice. The pie chart shows how Julie spent her weekly allowance from Monday to Friday in a particular week. Which of the following bar graphs represent the data shown in the pie chart? It's very hard to compare them, but looking at it, for example, Wednesday is quarter circle. Now, Friday is definitely more than that. And looking at it, we can say that the day in which Julie spent a lot of money or the highest amount of money is Friday. So we go back to the choices that see here. Yes, this qualifies for it because it says Friday is the highest. Here also Friday is the highest. These two qualify for it. But if I go for the other two options that you see here, Friday is not the day when she spent the highest amount according to the depiction here, because the bar for Friday is shorter than that for Wednesday. So this is definitely not a choice. Similarly, Friday and Wednesday, the amount of money spent on Friday and Wednesday seems to be equal here, which is clearly not the case. So we can remove these two and now concentrate on these two options only. Then Wednesday is the second highest uh, money spent on Wednesday. So here, if you look at it, both of them have Wednesday to be the second highest money spent. Both of them qualify. Now, looking at it, Monday is the lowest amount of money spent, followed by Tuesday and Thursday. Now you look here, Monday, and then followed by Tuesday and Thursday, I guess. And here, Monday and Tuesday seems to be equal amount of money spent, which is clearly not the case here. So using that as a reference, we will choose this. Although you see here, there's a very small difference between Tuesday and Wednesday, or they might be equal, which is not very clear. And from this also, it's a bit very unclear. So we will still give the benefit of doubt and choose one as the option. A book costs B dollars more than a pen. The total cost of a book and 3 pens is $20. Find the cost of a pen. So let's say I'm assuming this is a pen, for example. And a book is going to cost B dollars, whatever is exactly this same length here, plus B dollars. So let me just put plus B. All right. And the total cost of a book and 3 pens. So not just 1 pen. So I'm going to draw 2 more pens here, models for 2 more pens here. And this total cost is coming to $20. Find the cost of a pen. So if you look here, I have 4 identical units here. So 4 units plus B dollars is equal to $20. Now 4 units is equal to 20 minus B. You bring the B to the other side, it becomes minus. 4 units is 20 minus B. So 1 unit is equal to 20 minus B by 4. Because it's made of 4 identical units, one of them should be that the total divided by 4. So now you choose here 20 minus B by 4, and then you put a dollar because it's representing money. So this is the right choice. Let me show you how this can be done with algebra as well. The cost of a pen, let's say cost of a pen is X dollars. Now cost of a book is going to be X plus B because it is B dollars more than a pen. Now you're getting the total cost of a book, which is X plus B plus 3 pens. So 1 pen is X, 3 pens is 3 times X, 3X. That is equal to $20. Now in algebra, 3X plus X is equal to 4X. It's like saying 3 pens plus 1 pen. So that is 3 plus 1, 4 pens. So it's 4X here. Plus B equals 20. And 4X is equal to 20 minus B. And X is, you want to remove 4 from this side, you divide by 4 here and also divide by 4 on the other side. So 20 minus B by 4. So that is for the amount, the cost of a pen. So that is using algebra. You could use either algebra because this is for a primary six. You could use either algebra or model method, whichever is um, convenient for you. The postage rates of two different countries are shown below. For the first 20 gram of mass, for Malaysia, they're charging 85 cents. For Japan, $1.50. And for every additional 10 grams or less, remember, for example, after 20 grams, if you choose to just, your weight is just 5 grams here, then it will still be 20 cents. For 8 grams, still 20 cents. So until up to 10 grams, you will be charged 20 cents for Malaysia, 35 cents for Japan. So Kim sent a letter weighing 35 grams to Malaysia and a letter weighing 10 grams to Japan. How much did she pay altogether? For Japan, let's say. For Japan, it's 10 grams, and it did not even cross the threshold of 20 grams. So it is for the first 20 grams, how much ever it is, you're still charged $1.50. So it's 150. It doesn't mean whether yours is 10 grams, 15 grams, up to 20 grams, the charges, first 20 grams, the charges is 150. So this is the amount for Japan. For Malaysia, it's 35 grams, and which means I crossed this threshold. So I will be charged 85 cents, right, for the first 20 grams. Now, after that, how much more weightage is there for that? So 35 minus 20 gives me 15. And which means for the next 10 grams, so for the next 10 grams, I will be charged 20 cents. And do I have anything else left? Yes, 15 minus 10 is 5 grams, which also means additional 10 grams. So for that, again, an additional 20 cents will be charged. So that would be 20. This is for the additional 5 grams because up to 10 grams, they are going to charge another 20 cents. So total amount of money that is being charged for uh, the package sent to Malaysia is 12. So that will become $1.25. Whereas for Japan, it is $1.50. So 150 plus 125 becomes $2.75. So this is the amount of money that is being charged. So it's $2.75. In the figure BCD is an equilateral triangle. What does that mean? It means two things. One is BC is equal to CD is equal to BD. And also one more thing, that this angles, each of these angles are going to be 60 degrees. This whole thing is 60 degrees. Similarly, this angle is also 60 degrees. ABD is an isosceles triangle. ABD is an isosceles triangle with AD, this is equal to BD. So this, if these two sides are equal in an isosceles triangle, if these two sides are equal, the corresponding angles are also equal. So if this is 46 and this whole thing, because we are talking about this triangle ADB, this whole thing is 46. Find angle DCA. Now, first thing to note is this figure ABCD is a quadrilateral four-sided figure. The sum of all the angles of a four-sided figure, any four-sided figure, the sum of all these angles, that is equal to 360 degrees. Now, for this figure, we know that this angle is 60. This is 60 plus 46, and this is 46. We know three of these angles. So if you want to find the fourth angle, this total fourth angle, that will be 360 minus the sum of these three angles here. So what is the sum of the three angles? 60 plus 60 plus 46 plus 46. It's like 120 plus 92. So that is equal to 212 degrees. Now, if I want to find this whole angle here, so that should be 360 minus 212. And that is going to be equal to, how much is that? Let's say 88 plus 60, 148. Let me just double confirm that. 360, 212, 8, 5, 4, and 3, 148. So 148 degrees. So that is this whole angle here. Let me use another color to just highlight it here. So this whole angle here is 148 degrees. Again, if you look at this triangle ADC, this is an isosceles triangle because AD is equal to CD from from the information given earlier. AD is equal to CD, which means this angle here that we want to find out is equal to this angle here. Now, since these two are equal, and if we want to find the sum of these two angles, that is angle A here, this angle, and then this angle of C, that plus these two, that should be equal to 180 minus 148 degrees. And that is equal to 32 degrees. Now 32 is equal to the sum of this and this, but these two are equal. So one of them, that is angle DCA, that is equal to 32 divided by 2, which is 16 degrees. Because this angle DCA plus angle DAC, that is equal to 32 degrees, and these two are equal. So it's like saying two units, equal units, are is equal to 32, right? So 2 times this unit is equal to 32. So one of this unit is equal to 32 divided by 2, which is 16 degrees. So this is our right choice, 16 degrees. On the first day, Roy ate 3 more cookies than Jaya. On the second day, Roy ate 12 cookies and Jaya ate 8 cookies. Jaya ate 2 by 5 of the total number of cookies. How many cookies did Roy eat? So first, they finished it in 2 days, which doesn't seem to have any relevance with respect to the question, but they finished it. On the first day, Roy ate 3 more cookies than Jaya. So let's draw a model for Jaya first. Jaya ate, let's say, some amount of cookies. Then Roy ate whatever Jaya ate plus 3 more cookies. Now, on the second day, Roy ate 12 cookies. On the second day, this is day 1 actually, right? And day 2, Roy ate 12 cookies and Jaya ate 8 cookies, which is given straight. Jaya ate 2/5 of the total number of cookies. How many cookies did Roy eat? So Jaya, if the total number of cookies were to be divided into 5 parts. So let's say I draw this 1, 2, 3, 4, 5 parts. Jaya, whatever he ate is actually 2/5 of the total number. So this is what was eaten by Jaya. And this 3 units was what was eaten by Roy. Now, when you look at it, what is the only thing that stands out is Jaya ate 2 units of cookies and Roy ate 3 units of cookies, and the difference between the two is going to be 3 units minus 2 units, which will be 1 unit here. So the difference between Roy and Jaya is 1 unit, right? Now, this unit and this unit, they are not of the same size, so don't confuse that. But this is different. But we still have the total amount of chocolates or cookies Jaya ate and Roy ate. Now, how do I know who ate more? Looking at this is 1 unit plus 8 and this is 1 unit plus 3 plus 12, which is 1 unit plus 15. Now, what is the difference? Whatever Roy ate, minus what? JR 8. So basically, JR 8, 1 unit plus 8. And Roy 8, same 1 unit plus 12 plus 3, which is going to be 15 here. So the difference between them is Roy's cookies minus JR's cookies. So when I do that, this minus this will get cancelled off. 15 minus 8 is 7. So 15 minus 8 is going to be 7. So 7 is the difference. If the difference is 7, and in terms of units, you see here the difference is 1 unit. So 1 unit has to be 7. And if this is 7, each of these units, they are of identical units, so they will all be 7 here. So how many cookies did Roy ate? Roy ate 3 units, and each unit is 7, so 3 sevens, 21. So Roy ate 21 cookies. Ratio of the number of girls in team A to the number of girls in team B is 2:3. The ratio of the number of boys in team A to the number of boys in team B is 5:3. In team A, the ratio of the number of girls to the number of boys is 4:3. What is the ratio of the number of girls to the number of boys in team B? There are multiple ratios involved, and it's going to be a bit complex. So we will have to handle it carefully, one at a time. Let's start doing that. So the first thing is the ratio of the number of girls in team A to the number of girls in team B is 2:3. Let's go ahead and record that down with a model. See, this represents the number of girls in team A is to team B. That is given as 2:3. So we draw a model whereby you have 2 units for the girls in team A and 3 units for the girls in team B. And the next statement is about the ratio of the number of boys in team A to the number of boys in team B is 5:3. So that becomes like this. So the boys in team A is to team B is in the ratio 5:3. So the normal question is, why is it drawn bigger here and drawn smaller here? So first thing to note is, do not worry about the sizes. We just know that these and these are going to be different sizes. But one thing to note again is these units and these units, because they are connected by a ratio, they will have the same size. Whereas here, these two are connected by the same ratio, and so they do have the same size as well. You don't have to be drawing it small or big, you can just draw it anyway. And now after this, then there is this third ratio here, and that says the number of girls, the ratio, or this in team A, the ratio of the number of girls to the number of boys is 4:3. That is, the number of girls in team A, that is here, is to the number of boys in team A is given to be 4:3. So let's mark that this is about the girls in team A versus the boys in team A itself. So that ratio is given to be 4:3. So I've just put it in here to indicate that this ratio is between the number of girls in team A to the number of boys in team B. And why is this size the same as this? Because this also represents the girls in team A. This also represents the girls in team A. And this represents the boys in team A. And this also represents the boys in team A. That because the number of girls here in team A and the number of girls here in team A, the total is going to be the same. And here also, the number of boys in team A, and this is also number of boys in team A, and the total number of boys in team A, that has to be the same. So that's why I carefully put this to be equal in size here. But we also know that if these two are equal in size, here it is 2 units, here it is shown as 4 units. Now, if this is 4 units and this is 2 units, how do we make them to be of the same size? We use LCM of 2 and 4, and the LCM is 4, which means I will have to divide this into 2 units. Again, this into 2 units, so that they become 4 units here. Now, when I do that, I will also have to do that same here. That's what I've done here by these the markings here. So earlier it was 3. Now this was 2 times 2, 4. So this is 3 times 2, which is has become into 6 units here. Now here again, this is 5 units and this is 3 units. The LCM of 5 and 3 is 15. That's why here I made it as 5 times 3, meaning each of these I'm going to divide it into 3 smaller units, so that 5 times 3 I will have 15 such units here like this. I've divided further divided into 3 smaller units. Now if I do that, what should I be doing here? I should be dividing this into 5 smaller units. That is 3 times each into 5. That will also become 15. So 3 times 5 is 15, and I've done it here. I will be doing the same here, and I should be doing the same here also, but we just need to understand just the concepts. I mean, if assuming that we are going to do this here, and let's say we have done that here. And this is, I have not done that so as to avoid confusion and also to clearly show that this is what we are doing with these units. Now, when we do this here, what do you think will happen here as well? Because this is 5, each one into 3, so 5 times 3, 15. This unit and this unit is the same, which means I will have to do that here also, which means this will become 3 units. So 3 times 3 should become 9 units here. So this actually has become 9 units if I just put this thing here. All right. So then again, when I'm coming back here, this unit here and this unit here, they are of the same size, because that's how we put them as a ratio. They are connected by ratio. So this unit and this unit, they are of the same size, which means if I am changing this into 5 units here, I can do the same here, or I should do that same here, because only then all of these will have equal size units and we can compare that. So when I do this, it also means I will have to do this here. Here, each one is 4. I have 4 units and each is further divided into 5 units. So 4 times 5, I should have 20 units here. So this is equal to 20 units. And when I do the same here, this will also become 20 units. Now when I do this here, I should also do that here. Again, the total units that I have here should be, this earlier I had 6, each one divided into 5. 6 times 5, 30 units now. So now if you look at it, all of these are of the same unit sizes. So if now what is the question is asking is about the ratio of the number of girls to the number of boys in team B. So the number of girls in team B is 30 units is to the number of boys in team B, which is 9 units. So that is 30 is to 9. And again, we can simplify this because both are divisible by 3. We can make it into 10 is to 3, which is the required answer. Then now next, I'm going to do the same thing with algebra as well. So you can choose which method is easier for you. For the same question, the ratio of the number of girls to in team A to the number of girls in team B is 2 is to 3. And I'm not going to read that again. So let's just start with the first statement. The ratio of the number of girls in team A to the number of girls in team B is 2 is to 3. Let's record that down here. So here again, it's about girls in team A to team B is 2 is to 3. Now, the next statement now before we go there, see when we say 2 is to 3, it is actually can be written as 2x and 3x. Why is that so? Let's say the number of girls in team A is 15, for example. The number of girls in team A, let's say, is 15, and the number of girls in team B is 20. How is the ratio generally written? It is not written as 15 is to 20. It is simplified, and so both sides divide by 5, so it will be 3 is to 4. Now this is given as the ratio, but what is the actual number of girls in team A and team B? That we get by times 5 here and times 5 here. This 5 we do not know right now, and that is what we represent as x here. So it's given as 2x and 3x, meaning we know that we have to multiply with a particular number to get the actual number of girls in team A and team B. We do not know the number, so the unknown number is represented by x. And another thing to note is you will be multiplying both with the same number, right? It could be 5, it could be 10 or any number, but that will be the same. That's why we are able to use 2x and 3x here. So now, after this, the second statement is the number of boys in team A to the number of boys in team B is the ratio is 5:3. So we record that as well. The ratio of the number of boys in team A to the number of boys in team B is 5:3, and this again can be recorded as 5y and 3y. That is, 5y is the total number of boys in team A and 3y is the total number of boys in team B. Again, I used y because this you had to multiply by some number, and this could be multiplied by some other number. We do not know. So that's why we are using a different variable here. And the third statement that we see here is the ratio of, in team A alone, the ratio of the number of girls to boys is 4:3. So again here, team A, the number of girls in team A, to the number of boys in team A is 4:3, which can be written as the total number of girls in team A has to be 4z, and the total number of boys in team A should be 3z, because the ratio is 4:3. So the total number of girls will become 4z and the boys will become 3z here. And we also know that this 2 both represent the total number of girls in team A, which means 2x is actually equal to 4z and 5y is equal to 3z here. And now when we represent, let's say, this number of girls in team A to the number of boys in team B, how would we normally represent here? You have to represent as 2x, which is the total number of girls in team A, to 5y, which is the total number of boys in team A again. So that can be written as 2x over 5y, because the ratio, if it is 2:5, it can also be represented as 2/5 as well. Ratio can be represented this way. So here we are going to say 2x over 5y is equal to, because 2x is equal to 4z, that's it, 4z over 5y is equal to 3z, so we put 3z here. Now, although it is 2x by 3y, it can also be written as this 2 by 5 times x over y, which is the same, because when you multiply it will become 2x over 5y. And here 4z and 3z are nothing but 4 times z and 3 times z. So you know that these two can get cancelled off. The z and z, they get cancelled off. So we are left with 4/3. And this 2/5, when you bring it over, it will be times this 2/5 will become 5/2. So now, again, this 2 times 1 here and 2 times 2 here. So 5 times 2 is 10 and 3 times 1 is 3. So this would become x over y is equal to 10/3. So the ratio of x is to y is 10:3. Now, x is this factor here and y is this factor here. Now, before we go there, the question here is, what is the ratio of the number of girls to the number of boys in team B? We are now looking at the number of girls in team B to the number of boys in team B, which is basically the total number of girls is over the total number of boys. So that can be given by 3x over 3y, because here the total number of girls in team B is 3x, the total number of boys in team B is 3y. Again, that is also equal to 10/3, because x over y is 10/3, but 3x over 3y, which is basically times 3 times 3. I've just not put down there, but again these three will get cancelled. So the result would still be 10:3. So the answer is actually 10:3. Now, if you want to verify something, see earlier the ratio of the number of girls in team A to the number of boys in team A was 2:5, isn't it? But we also knew the total number of girls in team A was 2x, the total number of boys in team A was 5y. So I can write 2x over 5y. That is equal to x is 10. So I would say 2 times 10 over 5 times 3 here, because y is 3. That gives me 20 over 15. This on simplification would be 4 over 3, or in ratio 4:3. So does that match with what we got here? Yes. Now this is just for clarifying how ratio works. You don't have to worry about this part. The actual thing is we could stop here because this is the required answer. A sheet of paper in the shape of an isosceles triangle where AB is equal to AC. So this AB equals AC. Now, what does that help us? The length AB is equal to AC. It also means this angle B here is equal to angle C here. Now, it is folded along the dotted line BD as shown below. Find angle X here. Now, a few things to note here is, first, let's figure out what are these two angles and how do we do that. See, one thing we have shown here is this is 16 degrees. When you fold it, this portion here is what appears here. Let me show it to you in a different color. So this here, this angle here, this is exactly matching with this angle here. So this is 16 degrees. So it is shown that this guy here is 16 degrees. So we can infer that from here. Then if this is 16, what is this angle here? It's angle in a straight line. This is 80 degrees. So this should be 100 degrees. 100 plus 80 is 180. Now, can we find what is A from these two? Because we can look at this triangle ADB. This is 116. So you know that the sum of angles in a triangle is equal to 180. So this would be 180 minus 100 plus 16, which is 116. So from that, we can see that it's 64 degrees. So this angle here is 64 degrees. Now, once we know this is 64, we again know that these two angles are equal, and the sum of all the angles in a triangle is 180. So now what is the sum of these two angles, B plus C? So that is 180 minus 64, which means it is exactly the inverse of this. So 180 minus 64 will give you 116 degrees. And that is the sum of B and C. And we know they are equal. So B alone or C alone would be equal to, so angle B equals angle C equals 116 divided by 2. So that is going to be 58 degrees. So this whole thing here is 58 degrees, and this total is 58. Now I'm going to show you another thing that you will try to visualize how it works out. Say, for example, if I actually folded this, how would it have looked like? It would have looked like something like this, just like this picture here. This A came into this place. So we just folded it like this, which again means if you're folding this, if this was 16, this should also be 16 here. Is that right? So now, after you folded, you got a 16. This was 16 before, right? This is 16 again. And you know that the whole thing here is 58 degrees. So what is this angle here? That is 58 minus 16 plus 60. So this 16 plus 16 is 32. So this angle that you have here, this is equal to 58 minus 32. So 50 minus 30 is 20, 26 degrees. So this is equal to 26 degrees here. And now putting it back here, this is 26, this is 58. Now again, this is a triangle here. So what is the angle X? It is 180 minus 58 plus 26. So what is 58 plus 26? 78, 84 degrees, right? So what is 180 minus 84 degrees? So that is equal to 96 degrees. So the answer should be 96 degrees here. So this is involving find the value of 35.4 minus 9.72. So this is basically decimal subtraction. The rules to be remembered for decimal subtraction: align addition or subtraction of decimals. The first rule is align the decimal point here. So the next one is 972. And if there are no numbers at the end, you can replace that with a 0, because 0 at the end after a decimal does not have any value. So you can leave it like that. So use normal, whatever you would do for a normal subtraction, do the same thing. In this case, there is a 0 here. So I'll have to borrow 1 from here so that it becomes 10. 10 minus 2 is 8. Because I borrowed it over, now what I have left is 3. So again, I will have to borrow 1 from here. So it becomes 1, and then this becomes 13. 13 minus 7 is 6. Okay, now there's 4 here, which is smaller than 9. So again, borrow 1 from here, so it becomes 14. 14 minus 9 is 5. So the left here is 2. So answer should be 25.68. So the key things to remember: align your dots and then do a normal subtraction. Round 99652 to the nearest 100. So you want to round it off to the nearest 100. So look for the position 100. Ones, tens, hundreds. So this is where you want to round off. Now, if you want to round off to the nearest 100, then immediately look at the number next to that on the right side, right? Now, if this number is equal to or greater than 5, then what do? We add 1 to this number in the hundredths position. So in this case, it becomes 9, 6 becomes 7. Because this number here is 5, which is what we wanted. Like if it is 5 or greater than 5, we add 1 to the number here, 7. And then because after you do this, there is no need for these two, so we just replace them with 0. So the answer has to be 9700. Find the value of 4 over 5 divided by 20. Give your answer in the simplest form. Remember, 4 by 5 divided by 20. And again, best thing to do is write 20 in the form of a fraction. If I'm going to write 20 as a fraction, I would write it as 20 over 1. Right? Now, if I divide this, the working is like this: 4 by 5 divided by 20 over 1. And when you want to bring this up, what happens is, first you have a division. Division becomes multiplication, and this will be inverse. It will become 1 over 20. So that is what another way of looking at it is: 4 by 5 divided by 20 over 1. Change it into times. When you change this into times, it becomes the inverse: 1 over 20. So now 4 times 5 is 20. So this will be 1 over 25. So that should be the answer here. After Jenny made 135 degrees clockwise turn, she ended up facing north. What direction was she facing? South. So now she is in this direction. She is facing north. She did a clockwise turn earlier, which is wherever she was, she did a turn like this in a clockwise direction. So we have to do anti-clockwise now to trace back our steps to where she came from. Now, how much should we turn anti-clockwise now? Because earlier she had turned clockwise. To go back to where she came from, we have to turn anti-clockwise. And we have to turn anti-clockwise 135 degrees. We know that this is 45 here, right? And this is another 45. So this is actually 90. And 90 plus 45 will give you 135. So we know that 90 plus 45 equals 135. So I'm just going from here, 45, 45, 45. That gives me 135 degrees, and I have gone anti-clockwise direction. So basically she was facing southwest at first, and then she turned clockwise, which is in this direction, for 135 degrees, and he ended up facing north. So the initial answer should have been, the initial direction in which she had been facing was southwest. The figure shows a right-angled triangle. Find the area of the triangle. This is directly to confuse you, because we have all been used to the fact that the area of a triangle is half times base times height. And here they have shown you this to indicate that this is the height, and it is not given to us. So it's slightly there to just confuse you. But remember, it's a right-angled triangle. Now, what is the height or the altitude of a triangle? Basically, if you have a triangle like this, then it's from the one of the vertices perpendicular to the base of the triangle. But what if it was a right angle triangle like this? Then I could either use this as the height, because this is perpendicular to this, so this is the base. Or I could use this as the height and this is the base, right? So now, since they say this is a right angle triangle, just imagine if this was the height here, if this was the height, and then this would be the base as well. We don't have to look at for this one. Just look at this. This is the height and this is the base of the triangle. So basically half times base is 9 in our case, and height is 12. So 2, 6, 12, 6 nines, 54. So answer would be 54 centimeter square. We are going to the next section of the question paper. Each question carries 2 marks here. So let's see how we can do this. Measure and write down. This I'm not going to do here, but basically you have to use a protractor to measure, or first a ruler to measure the length of BC here. And the size of angle BAC, you'll have to use a protractor to measure and fill up this information. And now let's come to the next one. The first 6 numbers in a number pattern are given below. What is the 7th and the 8th number? So let's look at how these numbers are being generated. 2 became 5. So what is the difference between those two? 5 minus 2 gives me 3. All right. Let me check. 8 and 5. 8 minus 5 gives me 3 also. So 11 minus 8, that also gives me 3. So what I find here is the common difference is this. So basically 2 plus 3 gives me 5. 5 plus 3 gives me 8. 8 plus 3 gives me 11, and so on. So the common difference is always plus 3. This kind of sequences or patterns are called arithmetic progressions, where every subsequent number is but you get that by adding a common difference, that is in this case 3. What is the 7th and the 20th number in the pattern? Now we'll do a traditional way of solving it, and I will also tell you a a shortcut for these kind of problems as well. So first, let's take that. This is the first term in the sequence. Okay, I'm going to say this is the term. All right, let's say do this. This is the term, and then this is the value here. I'm going to show that here. And then now let me write down the first term, my value is 2. Second term, my value is 5. Third, sorry, this is the second term. The third term, my value is 8. Fourth term, my value is 11. Fifth term, it's 14. And sixth term, it's 17. So let me see how I can write this. In this one, I don't have to do anything. So this is just 2. But how did I get this? 5. 5 I got by adding 2 plus 3. Now, whatever 5 is represented by 2 plus 3. That is 5. But to that, I added another 3 to get 8 here. Then again, 2 plus 3 plus 3, whatever was coming to be 8. To that, I again added another 3 to get 11 and so on. So now, let me look here. Again, I want to just try to formalize this in a slightly different manner. Let's say 2 plus how many 3's are there in the second term? There is 1 times 3. Here, 2 plus 2 times 3. Here, 2 plus 3 times 3. And you find the relationship between some of the numbers here and the term values here. For example, 2 and 3 are constant everywhere, so we know that's not going to change. The only thing that is going to change here is the only thing that is changing here is this number here. 1, it becomes 2, and becomes 3. And how does it change here? Look at it. When the term number is 2, this is 1. When the term number is 3, it becomes 2. When the term number is 4, it becomes 3. That is, it is always 1 less than the term number. So in other words, I could also write this as this 2 is as it is, but here I'm going to say 2 plus, this is 2 minus 1, which is 1, right? 2 minus 1 times 3. Similarly, here it's 2 plus 3 minus 1 times 3. Here, this is 2 plus, this is 4 minus 1 times 3. I can do that also. So if it is 6, it would be 2 plus 6 minus 1 times 3. So that will give me the value. So if you want the seventh value, it will be 2 plus 7 minus 1 times 3. So that this is actually equal to 2 plus 6 times 3. 3, 6, 18. 18 plus 2 is 20. So this is your sixth value. And they want a 20th number as well. So if it is 20, I go by the same pattern here. 2 plus 20 minus 1 times 3, which is 2 plus 19 times 3. So what is 19 times 3? 57. So 57 plus 2 gives me 59. So that is the 20th number. So this is a traditional way of doing it. But if you go with these kind of sequences, you will realize that there is something here. Take a look at even this, what you see here. All right. In this case, see, what is this 2? 2 is the first number in the series. 2 is always the first number in the series. And what is this 20 here? 20 is that the number in the series that you want to find out. That is, let's say if this was n, for example, you want to find out that. If, example, let's take a case. If, let's say, you want to find out the 25th number, then that will be replaced here. So this is the number of the term number in the sequence. And what is 3? 3 is always the common difference. So in arithmetic progression, if you want to find the nth term, it is given as the first term in the sequence, which is 2 here, plus then n minus 1 times d, where d is the difference, n is the number of terms. So if you want to find out the 25th term, for example, what you can do is, okay, for this sequence, the first term is 2 plus. I want to find the 25th term. So 10 is 25 minus 1. And what is a common difference here? 3. So that will give me this. So 24 times 3. So 24 times 3 is 272 plus 2. Let me see. 24 times 3, 272. Yeah. So that will be 74. So you could just go ahead with this one shortcut if you are short of time. If you want to save time, you could use this. But this is the more traditional way of finding out. Eventually, in higher classes, you will learn about these formulas as well. But this is the basic. But how did we get this formula? You need to understand this to understand how we even got this formula. Information below to answer questions 23 and 24. Citi received a monthly allowance of $120 at the beginning of July. The line graph below shows the amount of pocket money she had left at the end of each week of July. So this is at the end of week 1, end of week 2, week 3, and week 4. Let's take a look at the end of week 1. See here, this refers to this is 80 here. So at the end of week 1, she has $80 left. So the question is, how much did Citi spend in July in total? So this whole of July means up to the end of week 4 of July. At this point here, now we have to look at one thing here. What is each of these lines here amount to? For example, this is a major ending here from 10 to 20. This, the length here is 20 minus 10, which is 10. So this is $10 here, represented value here. And out of that, each one is divided into 1, 2, 3, 4, 5. So 10 divided by 5 is 2. So each of these lines here represent $2. So now here it has crossed 10. So this we know because it has gone beyond this line, which is 10. And how many has it gone? From what I can see, 1, 2, 3. So 2 times 3, because each of these is $2. There are 3 lines here. 3 times 2, $6 here. So 10 plus 6. So this will represent $16 here. Meaning at the end of 4 weeks, she's left with $16. So initially, if you look at the question, she had $120 and now she's left with just $16. So how much she spent is basically 120 minus 16, which is equal to 104. So she spent an amount of $104. The next question is asking us, in which week did Citi spend the most? So now let's take a look at this. Initially, she had $120. At the end of week 1, she had 80, which means in week 1, starting off with $120, end of the week she had 80, which means she spent $40 in week 1. Week 2, when she started week 2, she had 80. At the end of week 2, she had, how much is this? 62? I think it's 64. So she started off with 80 and she had 64 left. So that is $16. So she spent $16 in week 2. Let's say week 3. Again, 64 is what she ended up with. Start here. Had 64 at the end of week 2. So at the end of week 3, she had 30, 32, 34. I think it's 36. If my eyes serve me correctly, it's 36 here. So from 64, she ended up with 36. So it's 64 minus 36. So that is going to be for the $28, right? And in week 4, she started with $36 and ended up with $16. So week 4 is 36 minus 16, which is $20 at the end of week 4. So now comparing this, in week 1 she spent $40, which is the highest. So this was in week 1. So week 1 she spent $40. And how much did she spend in that week? Yeah, $40. So the answer for the next question is going to be $40 here. So this question is, right angle triangle ABC is drawn on a square grid inside a box. By joining dots on the grid with straight lines, draw a parallelogram PQRS with perimeter twice or 2 times that of the triangle ABC. Parallelogram PQRS must not overlap with triangle ABC. So now you look at it, let's see what is the perimeter of this triangle ABC. AB is made of, like here, 1 unit, 2 units, 3 units, 4 units. So the length here is 4 units. For BC, it's 1, 2, 3. So it's 3 units. Now, having done that, it's not so straightforward to find the length of AC. But let us see this. See if this is how a parallelogram looks like. And I want to make sure that the perimeter of the parallelogram is twice that of this. Now, this is AC is one side. If I can draw another line somewhere here like this AC, and which represents this side here, right? And I will have another line which will be equal in length to this. A parallelogram will have two sides like this, and they are equal in length, which means the total length of this line and this line will be twice the length of AC. So now all I have to do first is draw a line like this. How do I do that? Now, if I start from here, for example, because I should not overlap, I'm doing it here. Where should I end with? Start here. It started here. It went 1, 2, 3, 4 down, and 1, 2, 3, 3 right. Do the same thing here. From here, 1, 2, 3, 4 down, and 1, 2, 3, 3 right. So this must be my end point. So I have to draw a line like this. Yeah, please draw a proper line. Probably use a ruler. Okay, this is the line which kind of doesn't look like a line, but I will assume that this is a line here. Let's say P and a Q. Now, I need to have another line which is exactly like this, but where should I draw? I'm not so sure. So let's come to the other part. See, this length is here, and if I have one more line, I have achieved twice this length. But this length plus this length is 4 plus 3. That is 7. I should have the other two sides should be 7 and 7, so that I will have twice 7. So from here I start 1, 2, 3, 4, 5, 6, 7 here. So I go have a line here, and again here 1, 2, 3, 4, 5, 6, 7. So I draw another line here, and now I join these two lines here. So if you look at it, this is 7, and I've achieved 7 and 7. 2 times 7 is I've achieved that here. And this is once this length, and this means I have twice the length. So in total, the perimeter of my parallelogram PQRS is twice the perimeter of this triangle ABC. 36 is a common multiple of A and B. B is 7 more than A. What is the value of B? We see that 36 is a common multiple of both A and B, which means A times something and B times something gives you 36. Let's look at what are the factors of 36. See, 1 times 36 gives me 36. 2 times 18 gives us 36. Similarly, 3 times 12 gives us 36. 4 times 9 gives us 36. And 6 times 6 gives us 36. So these are all the factors, because from this what we know is if 36 is a common multiple of A and B, then A and B are factors of 36 because I can say A times something equals 36. B times some other number that is also equal to 36, which means A is a factor of 36, B is a factor of 36, which means that 36 is divisible by A and 36 is divisible by B. Now, what is the relationship between A and B? We are not even worried about what these are. The question doesn't even care about what these are. All it says is B is 7 more than A. So now take a look at all these numbers because all these are factors of 36. Just pick up two numbers where the difference is 7. Now look at it. Say 9 minus 2 is 7, isn't it? But the other numbers, they don't match here, like 18 minus 4, no, 18 minus 3, no. So 9 minus 2 will give you 7. So the two numbers A and B should be, A should be 2, B should be 9. And the reason is B is 9 and not 2 is because B is 7 more than A. So the difference between these two should be 7. Find out a pair where the difference is 7. So in this case, the value of B has to be 9. This is the quickest way rather than trying to use algebra or models. This would be the best way to solve this problem quickly. The figure shows a cube which two nets are the correct nets of the cube. You will have to use visualization to really figure this out. For example, if I can fold it along this line, then it comes up. And I will be able to curl this. Once it comes up, this forms this side of this and this forms this side of it. If I can bring this up, yeah, and this will form the top cover of this. So A definitely is the right answer because imagine doing this, flipping this along this border line here, right? Now when you bring this up, this will be this side of it, and this will be this side of the cube, and this will become form this side of the cube, because after you bring this up, you bend it up, then you also bend along these edges to form this side and this side. Now after that, when you bring this up along this edge here, when you push this up along this edge here, this here will form this face of this cube here, this face, and this will form the top cover. So this is definitely the correct net of the cube. But they are saying which two nets, so we'll have to look for one more. Let's look at it. If I bring this up, no, this will never work out, because if I bring this up, then I have these two as the base, and this is also on these two sides, so this is definitely not going to work out. Let's take a look at this one. Yeah, look at it. I'm going to bend this like at this. Let's say this is my base, for example. This becomes my base. All right. So when I bring this up here, this will form this side and this will form this side of the cube. Now when I bring this up along this side, this guy will form, this face will form this edge, and this becomes the top of the cube, because again I forget bend it along this edge. And after you do that, when you bend it along this edge, this will form this face of this cube. So this is a right answer as well. So we can directly say these two are the right answers. Again, when you look at it, if you here bend this side will form this face, and after bending it here, this will form this face. That is okay. But when you bend this over here, there's only one way these all goes, because when you bring this up, after you bend this again, this will form the top, this will form this face, this will form the top of this, but this will try to form this face, which there is already one there. There's been overlapping. There is nothing that is covering this area. This face is not covered. So only A and C are the right answers. Mr. Ang and Mr. Lee were 120 kilometers apart. They drove towards each other, starting at the same time.
Mr. Lee's average speed was 10 kilometers per hour slower than Mr. Ang's average speed. 45 minutes later, they passed each other. What was Mr. Ang's average speed? So this is a speed related problem. I would always like to come up with this diagram first. Distance, speed, and time. D comes first in your alphabetical order, so you put D here. S and T come next to each other, so we put S and T here. So the formula is speed is equal to distance over time, or time is equal to distance over speed, or distance is equal to speed times time. So this is an easy way to remember the formula. That's why I brought it up here. So now first, Mr. Ang and Mr. Lee were 120 kilometers apart. Let's plot that down. This is Mr. Ang driving from here and Mr. Lee, and the distance between them is 120 kilometers. They drove towards each other starting at the same time. So they are driving towards each other. So the category of this question is moving in opposite direction. So this is about moving in opposite direction. And when they move in opposite direction, what is a significant factor to remember? That is, both of them together are covering this distance 120 kilometers. So at a given time, this would have covered half of it or some part of it, and Mr. Lee would have covered the other part of it. So totally together, they are covering this distance, which means we add up their speed whenever you want to find something here. Now, in this case, it is shown that Mr. Lee's average speed was 10 kilometers per hour slower than Mr. Ang's average speed. So he is slower than this. But before that, 45 minutes later, they passed each other. What was Mr. Ang's average speed? So 45 minutes later, what exactly happened in 45 minutes time? He would have covered somewhere here. So here, they would have met at this point, somewhere around here, right? So when they meet at this point, Mr. Ang would have covered this much entire distance and Mr. Lee would have covered this distance. So totally they have covered 120 kilometers. And in how much time? In 45 minutes. And looking at it, you see this is given in kilometers distance, and the speed also, when they're referring to 10 kilometers per hour slower. Now, but the time is given as minutes, so it is better we convert this into hours. So first 45 minutes is equal to 45 by 60 hour. That is, when you want to convert minutes into hours, you divide it by 60, and on simplification, this would become 3 by 4 of an hour. So that is the time here. Now we take a look at this statement. Mr. Lee's average speed was 10 kilometers per hour, slower than Mr. Ang's average speed. So first let's say Mr. Ang's speed is this, because Lee's speed is dependent on Mr. Ang's speed. So we put Mr. Ang's speed first to be some value, and Mr. Lee's speed is going to be 10 less than Mr. Ang's speed. So this distance here is 10, because that is how much Mr. Lee's speed is less than Mr. Ang's speed here. So this is going to be 10. Now in algebra, you could represent Mr. Ang's speed first with x. If this whole thing here, this entire value here, if this whole thing is x, then how much is this? This is x minus away this 10. So that Mr. Lee's speed will be x minus 10. Now, the formula is speed is equal to distance by time. We know that the distance is 120 kilometers. We also know the time, so we can equate it like this. Speed is equal to distance by time. But when it comes to the speed, because they are moving in opposite directions, both of them are covering this distance together. We add up their speed. So the speeds are x and x minus 10. So we add up x plus x minus 10 is equal to, the distance is 120 divided by the time is 3 by 4. And 120 can be written as 120 over 1 divided by 3 by 4, which will come into 120 over 1 times 4 by 3. Divided by 3 by 4, when you convert it into times, it will inverse and it will become 4 by 3. And on the left hand side, x plus x is 2x. So 2x minus 10 is this much. Now we also know that 3 times 40 is 120. And 4 times 40 is 160. So 2x is equal to this minus 10 comes over here, will be 160 plus 10, and x is equal to, this is 170 divided by 2, which is 85 kilometers per hour. That is Mr. Ang's average speed.
ABCD is a rectangle. AFC, AFC and GFE are straight lines. ADEF is a trapezium with AF parallel to DE. So these two lines, AF and DE, these two are parallel lines here. Now find the following angles, angle AFG. AFG. See these two, AF or AFC, it's because it's a straight line, that and DE, they are parallel lines. So if you have two parallel lines like this and you have a line that cuts across this line is called a transversal line. And in that scenario, this angle's here, that is on the top side, on the left side. Again here also on the top side, on the left side. So these two are corresponding angles and they are equal. Now when you take that concept here, AFC and DE are parallel lines, and EFG, this is a transversal line. So this is on the same side, on the top side, 112. This is also on the same side, the left side on the top side. So this is also equal to 112 degrees. So angle AFG is going to be 112 degrees. The second question is angle DAC. They want to find angle DAC, so which is this angle here. Now, in this triangle, first thing to note is it is said ABCD is a rectangle. ABCD is a rectangle, which means this angle that we have here, this has to be 90 degrees. That we know. And in this triangle AFG, we know two of these angles. Can we find the third angle here? And this third angle is 180 minus 112 plus 43. So 112 plus 43, that is 155 degrees. So this is 155 degrees. And so 180 minus 155, that is going to be equal to 25 degrees. So this is 25 degrees. And we know that this whole thing is 90 degrees. So this angle, if you want to find out just this angle, which is DAC or DAF, that is going to be 90, the total, minus of this 25. So 90 minus 25. So that is going to be 65 degrees. So the answer DAC is going to be 65 degrees. Find the perimeter of the figure below. Before we even start this, one assumption that we'll have to make is, for example, this line here is parallel to this line and to this line and to this and this lines. That is an assumption we will have to work with to solve this. Similarly, this line here is parallel to this line and to this line and to this line. Right? With that assumption, we'll go ahead and solve this. Now, perimeter, so this is 10, which we already know. Now, what about this here? This length that you see here. If you hear from here to here, it's 12. Again, from here to here is 3 centimeters, and that's why we assume that this is parallel to this. Only then, if this is 3, from here also it will be 3 centimeters, and then this whole thing will be parallel to this in this, so that becomes 12 plus 3. So this is 12 plus 3, which is equal to 15 centimeters. And since this and this are parallel and they are equal in this case, so this is also equal to 15 centimeters. Now these are okay because I can, from here it's 15, 10, 15, and I know that from here to here is 12. Now the question comes into how do we account for all of these? Now this alone, this entire thing is 10, but there is a gap here. And I only know this is 4. I don't know how much is this or even how much is this and how much is this gap. I don't know. But if you take a look at it, if you extend this up to here, for example, this is 4 centimeters that I know, right? So if I extend a line, straight line, this may not look like a straight line, but imagine that it's a straight line. So if you have a straight line that is put up here, this small piece, if I'm able to just cut it from here and put it here, right? Now, I don't have to count this here. I will not going to count it here, but I'm going to count it here. That's it. Then what happens? The moment I put this whole thing, inclusive of this piece here, this becomes 10 centimeters. Now, this length I know is 12 centimeters given. And if I take this piece here, what about this length? This is 4 because of this length here. This is 4, so this will also be 4. Now, should I be worried about finding out how much is this? Yeah, but then, see, I don't know how much is this, and I don't know how much is this. But this length, if I just add it to this length here, this is only for the purpose of finding the length. I'm not actually moving it here, but this length plus this length is equal to this total length, which is equal to 12 centimeters. Isn't it? So now let's take a look at this. This thing is 15 plus 15 plus 10 plus 10. So 15 plus 15 plus 10 plus 10. Now what about the lines inside that I need to? This is 12. Similarly, this plus this is also 12. So I have plus 12 plus 12. Now there is a 4 here and another 4 here. So plus 4 plus 4. So that is the perimeter of this figure. So this is 30 plus 20 plus 24 plus 8. So 50, 74, 82. So answer is 82 centimeters. So we move on to the next section of the question paper. Each of these questions have 2 marks. The full marks for each test is 100. In the first 4 tests, Ali scored an average of 68 marks. You know that the average is always like, there are 4 tests. Let's say I have some mark here. I have some mark here. These are not the same marks, okay? So, and I have another mark here, which I don't know. Consider this as blank. If I have 4 of marks and then I add all of them and divide by the total numbers, that is 4 marks. So divide by 4, that gives me the average of this, and that according to this is given to be 68. Another way of looking at it is the sum of these 4 marks is actually 68 times 4. That is the sum of all the 4 marks. But if you want to have another mark, see, the sum of the 4 marks is already 68 times 4. So this is 68 times 4, which is the sum of 4 marks. To this, let me add the 5th mark, which I don't know how much that is. And if I divide by 5 now, because this is 4 marks plus 1 mark, the total is 5 marks, divide by 5, that gives me the average of the 5, and I want it to be 74. So the question now is, how much is this? First, if I want to remove this 5, what I normally do, one way is I can say bring this 5 because it is connected by division, comes here, it becomes times. So that is one way. Or if I want to remove this, I multiply both sides by 5, meaning this 5 gets cancelled, I have times 5. Either way, you know what happens here. Now, after that step is over, if I want to find out this is 68 times 4. When I bring this over here, it will be minus 68 times 4. So this is equal to 74 times 5 minus 68 times 4. And that is equal to, what is 74 times 5 here? 370 minus 68 times 4. 272. So let me say 272, this becomes 8, so this becomes 16, 9. So I will have to score 98 in the final test or the fourth test to get an average of 74. So the answer is 98. Jane spent 3/5 of her money on a pair of shoes. So 3/5 of her money. So this is the total money, and the total money, you're dividing it into 5 parts. So let me draw a slightly bigger one, and 1, 2, 3, 4, 5. And out of these 5 parts, 3 of that part she's using on a pair of shoes. So this is used for a pair of shoes. Now she spent $5 more than 1/4 of the remainder on a dress. So this is the remainder. So up to here is this. So we have these 2 units. This is the remainder, but this you're talking about 1/4 of this, which means this total, I'm just drawing the exact same thing here. I could do it here also, but just to make it easier, I'm just drawing it here. I have to divide this into 4 parts like this, which means each of these I'm going to divide into 2 parts. So I get total of 4 parts. And she's spending $5 more than 1/4. Of these 4 parts, she's spending one part of it plus a $5. So that plus 5 can go up to here, it can go up to here, up to here, up to here. I do not know, but at this point, that is not very important. All you need to know is just put a marker somewhere here. Let's say this is 5. All right, I'm just going to do $5. The dress, this is for the dress. This is the total amount that she spent for the dress. And it says the dress costs $35. Out of this $35, this is $5. If you take away this, the remaining, this whole thing is $35. And if you take away the 5, this remaining thing here, that should be $30. That is 1 unit here that you have drawn here, this is equal to $30, which means this unit is also 30, this is 30, this is 30. And similarly, if you look here, this is the equivalent here, which means this is made of 4 units here. This is 30, 30, 30, because these are identical units, it has to be 30. And similarly, these guys have to be divided to be made it into 2 parts, each of them, so that the unit sizes are the same. And when the unit sizes are the same, each of these units are equal to $30. So how many such units are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because you had 5 units divided in each unit into 2 parts. So 5 times 2, we have 10 units here. So that is the amount of money she had at first. So 1 unit is $30 from what we see. So 10 units will be 30 times 10. So that is equal to $300. So that is the amount of money she had at first. So the answer is $300. The dotted line is the line of symmetry. Complete the figure to make it symmetric by shading the least number of squares. Now, you see here, this is the line of symmetry, which means on the upper side and the bottom side, both should have like equal shaded portions here. So this you have divided by, this is made of a square, all right? This is made of squares actually, which means, okay, this and this, the diagonal divides the square into two equal parts. So this is equal, this to equal. So I have equal on both, equal areas on both sides of this line. This is okay. Here again, there is one, and this is one here. So there is like one square on the top side, one square on the bottom side of the line. So this is again symmetric. Now you look at this. This is how much away from this particular thing. If I take a look at this, it goes like this, right? So now I do the same thing here. This is kind of a part of a diagonal. I complete this diagonal here. And then I have one more square, diagonal across one more square. And then I have the square which is shaded. So I can shade this here. So this is my shaded square. I've shaded one square. Now up to this is symmetrical. And here again, if you look at it, this is, let me take just this one alone. This is half a square, that is along this diagonal. That is other side, and this side I have one half, which is equal. But after this, I have one more square here along this diagonal. So take a look at this. Along this diagonal, I have one more square here, which is not there. So I have to shade it there. If I shade this, then this square matches this square here. So these two are of equal size. So this is making it make along this line, they are now symmetrical. Now there's one more square here. Now I can draw a diagonal like this. This is one square. Where is this equivalent square here? It's not shaded. So I have to shade this square. Now once I do this, this and this is equal. On top of this line, half of this square plus one square, and bottom also half of this square plus one square. They are equal. Then here one square, here one square, here a square, here a square, and there is half of this square along this line here, you see here, and the below also I have half a square here. So these are now the figure, or the squares that are shaded are now symmetrical across the line that is given here. So we have shaded 1, 2, and 3 squares. So that is the least number. The reason why they say least number of squares is this is minimum that you have to do to make it symmetrical. Can I do more? Yes, of course I can do more. Like for example, take here, if I shade this piece and this piece, yeah, that also makes it symmetrical. But it's about the least number of squares, so I don't have to add this to my answer here. Let me not add this here. So only 1, 2, 3. By just making this, I have made this figure symmetrical. The figure shows a cuboid container which is partially filled to a height of 5 centimeters. This is shown here as 5 centimeters. To fill it completely, 1386 cm cube of water must be added. What is the height of the container? So it's very simple. See, what is the volume of water currently that is there? That is 18 times 11 times 6, which is the volume of this shaded portion here. So volume of water is going to be volume of water is 18 times 11 times 5. So 5 times 11 is 55, and 18 times 55 is 990 cm cube. Now, to this, you're going to add 1386 cm cube to make it whole. But again, remember, there's one way of looking at it. Your base length and width, they are never going to change. So this is already 5 that you know here. We just need to figure out what is this. And to find out this, one way is we don't even have to find out this actually. I could have straight said, okay, 1386, because how did you get 1386? That is this, whatever is the height, let me show the height as h, for example, times 18 times 5, right? So that will give you, that is, this is equal to height times 18 times, sorry, 11, right? So 18 times 11, that will be equal to 1386. So height of this should be 1386 divided by 18 times 11. Now we can figure out how to find this out. Let's say, is this divisible by 11? Let me try. 1386 by 11 ones 11, so I have 28, 2, 22, I have 66, so 6. So basically this is 126. And then what is 126 divided by 18? So 126 divided by 18 is 18 times, this has to end with 6. So what gives me 6? 2 eights, 16, but that will be too small. 3 eights, 4 eights, 5 eights, 6 eights, 7 eights. So times 7, let's say. 7 times 8 is 56. 5, 7, 1, 7. So 126. Sorry. 18 times 7 gives me 126. So again, 18 times 7. So this height here is going to be 7 centimeters. I need not have found out this volume of the water here. That is another approach that we could do, but this is the best and the simplest one. So we can directly go with this method. Alice took 60 minutes to walk from point A to point B, which was 3,500 meters apart. In the same amount of time, she could run 7,500 meters from point B to point C. What is her average speed from point A to point C in kilometers per hour? So basically, she took 60 minutes from here to here. Again, here also, she's going to take 60 minutes. And the speed is asked in kilometers per hour, which means 60 minutes is 1 hour. And this is 1 hour. So what we have to do in such a question is that find the total distance. The total distance is 3,500 plus 7,500. 7,000 plus 3,000 is 10,000. 500 plus 500 is 1,000. So it basically the total distance is 11,000 meters. And in terms of kilometers, how much is that? You're converting meters to kilometers. You divide by 1,000. So when you divide by 1,000, you get 11 kilometers. And the time we want in hours. So here, total time taken is 2 hours. So 11 by 2 hours. So that is equal to 11 divided by 2 is going to be 5.5. So 10 and then 5. So it's 5.5. Use the units as it is, kilometers per hour. So that is her average speed from point A to point C. Anytime you want to find the average speed from 2 points, you cannot take individual units separately. Take the total distance divided by the total time taken. That gives the average speed. Marbles were packed into 3 bags. Bag A contained 15 N marbles. Bag A had 3 times as many marbles as bag B. Let me say put for bag B first. So bag B is my reference. So I had bag B and A had 3 times as many as bag B. So let me put A has 3 such units here. Right? So all these identical sized units. And let me see about bag C. Bag C has 5 more marbles than bag B. So whatever bag B has there, plus 5. So let me see, this is 5. This can be up to here. It doesn't matter. I just need to know this is 5 here. And it also says there were 75 marbles in bag C. So this total is actually 75. Now, another information is bag A contained 15N marbles. This whole thing is actually equal to 15N. And remember, 3 units is equal to 15N. So we normally write 3 units is equal to 15N. So 1 unit would be 15N divided by 3, which is 15 times N divided by 3. So 3 times 1, 3 times 5. So that is equal to 5N. So what it means is 1 unit is equal to 5N, which means this is 5N here. 5N, 5N, and this size is the same as this, so this will be 5N, and this is also 5N. Now we know 5N plus 5, that is equal to 75. So let's say 5N plus 5, that actually is equal to 75. So subtracting 5 on both sides. So minus 5, this gets cancelled. I will have minus 5 here. So 5N equals 70. So N is 70 divided by 5, which is equal to 1, 4. So N is 14. So find the value of N. So N is 14 in this case. At an event, there were a total of 101,446 boys and girls at first. During the break, 20 boys and 3/8 of the girls went home. The number of girls remaining was 1/3 the number of boys remaining. What was the difference in the number of boys and girls at first? Let's take a look. At an event, there were a total of 1,400 boys and girls at first. During the break, I do not know how many boys, so some boys, and 20 of them left. So this is the boys. Some amount of boys were there, 20 plus 20 of them left. And 3/8 of the girls went home. So whatever was the girls, we do not know how much or how big I should draw this, but let me just draw this 1, 2, 3, 4, 5, 6, 7, 8. Assuming the number of girls is divided into 8 parts, the total number of girls is divided into 8 parts, 3 of them went home. So this is the number of girls that they left. The number of girls remaining was 1/3 the number of boys remaining. See, 20 boys left. So this has to be the number of boys that are left. And if I divide this into 3 parts, all right, this is 1 part out of the 3 parts here. And the number of girls remaining was, that is, this is equal to this 1 part here. So my drawing is, of course, since when I started drawing, I didn't have enough information. I drew something like this, but so this is not, what I've drawn was not correct. So the actual drawing should have looked something like this, right? Say this plus 20. And I divide this into, let's say, 3 parts. Now this for the girls should have been equal to how many? 1, 2, sorry, not this actually. Let me go back. 1 part of the boys. If I divided the remaining boys into 3 and 1 part of that is equal to the number of the girls remaining. That is, the number of the girls remaining is actually 5 parts from what I know. So basically, this is the number of girls remaining because that is equal to the 1 part of the number of boys remaining. And this is divided into how many parts? 1, 2, 3, 4, 5. So the girls that left is 3 units here. 1, 2, 3. So this is the number of girls that left. And this, let me bring a different color here to show you clarity. This is 1 part out of 3 parts of the boys that were left. And that is equal to the number of girls that were left according to my previous diagram. So normally when you draw a diagram initially, you won't be able to give an exact picture here. So I'm just doing this so that you know that you don't have to worry that, how come this is big and how come this is equal to this. We didn't draw this knowing all this information. So now we are correcting the diagram here like this. So this is how it should have been actually. So you look at it, there were some boys, 20 left, and girls, 3/8 of the girls went home, meaning if this was the number of girls, I divided it into 8 points, 8 parts, 3 of them left. So this is remaining. And it says the remaining number of girls is equal to 1/3 of the number of boys left. This is the number of boys left divided into 3 parts. One part of that is equal to the number of girls left. So the question is, what was the difference in the number of boys and girls at first? And this whole thing, remember, this is equal to 1446. Now, if you know that each of this 1 unit is equal to 5 units here, so I can convert this into 5 units here. I can draw this, which means this will also be 5 units. This will also be 5 units here. So the total number of boys at first is 5 3s 15 units plus 20. Here I have 5 plus 3 units, which is 8 units here. So 15 plus 8 is 23 units. So 23 units plus this 20 here, that is equal to 1446. And what is 23 units equal to? 1446 minus 20, so that will become 1426. So 1 unit is 1426 divided by 23. Let's try that. 1426 divided by 23. So 25, there are 4, 5, 6, maybe 6, 3, 6, 18, 8, 1, 2, 6, 12, 13. So it's close here. So let me see, take 12. So this is 46. So 23 times 2 gives me 46. So 1 unit is equal to 62 here. So question is asking about what was the difference in the number of boys and girls at first. One way of doing it is 15 units, 15 times 62 plus 20, and then you find out 8 units, 8 times 62, subtract the 2. Yeah, that is also a feasible one. But the simpler way could be, since we know the number of units here, this is 5 here, this is 5 here, these two will get cancelled, then I subtract, find the difference. And here is 5, here is 3. When I subtract that, I will be left with 2 units here, right? Equivalent of 2 units I will be left with here. So this is cancelled, this cancel out. So 5 units plus 2 units is 7 units plus 20 is what is left. The number of boys that are more than the number of girls is this much. So 7 times 62. 62 times 7. 434. So 434 plus 20. So that is equal to 454. So that should be the answer here. I hope I made all these calculations correctly. If I have made any mistakes, do highlight in the comments section so others can benefit as well. The amount of money Bala had was 60% that of Alan. Alan had $52. How much was Bala's money? Or how much did Bala have? Bala had 60% of Alan, and Alan had $52. So Bala's money is equal to 60% of 52, which is 60 by 100 times 52. So it's a matter of calculation. See how much it comes to. 60 times 52. 260, 120, 30. So 3120 is the total. So that is 3120 divided by 100. And you know, if there are 2 zeros in the denominator, so starting from the right end, you have to pass 2 digits, 1, 2, and then put a dot here. So the answer should be $31.20. $31.02. After receiving some money from his mother, Bala's amount of money increased by 20%. By what percentage must Alan's money decrease so that they have the same amount of money? So there are two things here. One is Bala's money increased by 20%. He had $31.20. Now you have to increase by 20%. So 20% of this is what has to be increased to this. So what is 20% of 3120? So let's figure out what is 3120 times 20. So this 0 is not really, does not have any value here. So 31.2 times 20, and there's a 0 here, which means it's like times 10 actually. 20 is times 2 times 10. Let me just show you. 31.2 times 20 means times 2 times 10. So this 10 will actually move the decimal point to the right one. So I can also write it as 312 times 2. So this is 2 2s 4, 2 1s 2, 2 3 6. So the answer has to be 624 divided by 100. And that is equal to, again, two zeros here. So start the decimal point right now is here because it's $624.00. So it starts from here, and then since you're dividing by 100, which has two zeros, you have to move this dot 2 points, 2 digits to the left. So it will be $6.24. So you add this here. So it becomes $37.44. That's what right now Bala has after receiving some money from his mother. Now, Alan had $52. So what percentage of money should he give away, or his money should decrease so that they have the same amount of money? If they want to have the same amount of money, from 52 he has to come down to 37.44. So we have to find the difference. 52 minus 37.44. So it's decimal subtraction here. So when you borrow one from here and then one from here, this 10 minus 4 is 6. This is 9 minus 4 is 5. This is 1 because you borrowed out 1 here. So again, you have to borrow 1 from here, make it 1, and this becomes 11. So 11 minus 7 is 4. 4 minus 3 is 1. So he should give away 14.56 so that he will be left with 37.44. Now, how much money he has to decrease for Alan? That is $14.56. That is the amount of money that should be taken away from $52. This is for Alan. So we should take away 14.56 so that from 52 he can come back to 37.44, so that the money that he has will be equal to the amount of money Bala has now. So, and this is what percentage of 52? So this is given by 14.56 out of 52 times 100. So that will give you the percentage of 52 that this 14.56 represents. So that would be 1456. Remember, there are two zeros here. When you multiply here, this dot, when you multiply, and depending on the number of zeros, this dot goes to the right. So it goes 2 digits to the right, 1456 divided by 52%. So how much is 1456 divided by 52? I think 52 times 2 will be 104. Let's say 104. And that is equal to 1416. The remainder is 41 and then 416. And 52 times what will give me 6? 52. See, the ending number is 6. I'm just looking for probably a good real, not a decimal number. So I'm just thinking if I do with 3, I will get 3 times 2 is 6, right? But 3 is too small because 3 times 50 is 150. I need 4 here. So the other number when I multiply that will give 6 is 8. All right. So that seems to be an okay number. 2 8 16, 1, 5 8 40, 41. So 416. Okay, good. So now I will choose 8 here. So it's 416. So the answer here is 28%. So by what percentage must Alan's money decrease so that they have the same amount of money? It should decrease by 28%. If you have any difficulties in understanding any of these steps, or if you think there are gaps in explanation, do let me know. I'll try to come back with a reply video for that. The bar graph shows the number of cars sold at 4 different shops, A, B, C, and D respectively. The bar for shop C is not drawn. Probably it was not drawn and somebody drew up this as part of the answer. I think that's where when they took the original question from somebody, I think the answer was there. It may be right, may not be right. Let's just verify this. The question is, the number of cars sold at shop C was twice the number of cars sold at shop A. How many cars were sold at shop C? So C is twice A. So try to take a look at how much were there at A. See, it was 80 plus 1 unit here. Now let's see how do we find out how much actually it is. 80 to 100, the distance is made of, or each of these distance, like 40 to 60 or 80 to 100, these are all 20, right? Because 100 minus 80 is 20. And that is being divided into 1, 2, 3, 4 parts. So 20 is the total distance between these two, between 80 and 100. And that is divided into 4 parts. So the answer is 5, which means each of these divisions is 5 units. Now, if this is 80 plus there is goes up to one more unit. So it is 85. The number that you have to see here is 85. So this is 85. I hope it's clear. Yeah. So this is 85. So C, the cars sold at shop C was twice the number of cars sold at shop A. So if A is this much, B is twice, so 2 times. So this is 85. So this is 85 times 2. So that is equal to 170. I don't think they've asked us to draw that here, so that's okay. So shop E sold 175 fewer cars than the total number of cars sold by shop A, B, and D. How many cars did shop E sell? So for this one, we have to find out what is the total number of cars sold by A, B, and D. So first thing is A, we know 85. B is 100. It clearly marks up to here, so I can easily put it as 100. D is also 140. So A plus B plus D. They sold 140 plus 100 is 240, 240 plus 85. So that is actually 100 plus 140 plus 85. So that is equal to 200, 280, 320, 325. So it's 325. Now, shop E sold 175 fewer cars, meaning that A plus B plus D, if I were to represent this by a model like this, then E would be lesser. And how much lesser? 175 lesser. And we know that this whole thing is 325. So 325 minus 175, that will give the number of cars sold in shop E. So 5 minus 5 is 0. 12 minus 7 is 5. 2 minus 1 is 1. So in shop E, 150 cars were sold. So the answer here is 150. Tracy had 5 more 50-cent coins than 20-cent coins. After she used 8 50-cent coins, the value of the 50-cent coins is $6.30 more than the value of 20-cent coins. How many coins did she have at first? So Tracy had 5 more 50-cent coins than 20-cent coins. So let's take this 50-cent coins. If this is the model that I draw, so I had plus 5 more, right? So I can say it's something more here than 20-cent coins. So 20-cent coins is my reference. So I should have drawn this first, 20-cent coins, and then 50-cent coins is 5 more than whatever I had here. Now, after she used 8 50-cent coins, so which means she's using this 5 plus another 3 coins here. So she's using up this much, which means here how much of the money is she using up here. So if you use the 5 coins additionally, that's fine, but this 3 coins is equal to 3 times 50, that is $1.50. There's 3 coins here, this is the number of coins, the value of these 3 coins is 150, isn't it? Now after she did this, after she used 8 50-cent coins, the value of the 50-cent coins is $6.30 more than the value of the 20-cent coin. So the value of this, whatever number of coins, is $6.30 more than the 20-cent coins. Now you look at it, how many 20-cent coins are there? There are 3 more 20-cent coins when you look at it, right? So the value of this, whatever this number here, that times 50 cents, that is 630 more than whatever this plus 3 times 20. So how much is this here? This is 3 coins, 20 cents coins will give me 60 cents. Let me change a different color just to show some variation here. So the value of this 50-cent coins, I do not know how many ever this is. So let me take this as this value, all right? So this thing, I'm just, instead of drawing a bigger box, I'm just drawing a smaller box here. That times 50 cents. That. And on the other side, I'm comparing the same number of 20-cent coins. But I also have additionally 60 cents. And when you compare these two, the value of this is more. And how much more? 630. And since this is more, just think of it like a scale here. Normally, when you put a scale here, this is more. I mean, this will go down. If I want to make this to be equal, I have to exactly put whatever is the difference in here. So what I'm going to do here is, let's say, times 50 cents is equal to this times so many 20 cents plus 60 cents plus $6.30. So this many 50 cents is equal to the same number of 20-cent coins plus $6.30 plus 60 cents. So that is equal to $6.90. But remember, this is the same number of 50 cents and the same number of 20 cents. Now, can I subtract what is the difference between these two? If I take this, that will be that times 50 cents minus that same thing times 20 cents. That is equal to $6.90. It's like, for example, you have 10 50-cent coins. All right, 10 of these 50-cent coins are there. And then you have 10 20-cent coins. What is the total amount of money that you would have? Let's say this is 10 times 50-cent coins. minus 10 times 20 cent coins. So, yeah, 20 cent coins. So 10 50-cent coins minus 10 20-cent coins. So what would happen actually here? That you will be left with 10 times 30 cents. So that is what is going to happen here. So that whatever is this unknown number times 30 cents is equal to 690. And this unknown value will be 690 divided by 30 cents or 0.30. And when you deal with decimals division, first objective is to convert them into non-decimal numbers. How do I do that? Because there are two numbers after the decimal point and two numbers after the decimal point. So I can actually, or zeros, I don't even have to worry about the zeros. They don't have any value. So I can consider that as 6.9. I can rewrite this as 6.9 over 0.3. So times 10 on the numerator and denominator, this will become 69 and this will become 3. It's the same. So you can find out what is the answer here. This will become 326 and 3 is 9, so that is 23. So the number of coins, the value of this is 23 coins here. So how many coins did she have as this? This value, this is what I represented here. So this value in terms of the number of coins was 23, because we got the answer 23 here. And so this is also 23. So how many coins did she have at first? Look at it. She had 23 plus 3 plus 5. Here also she had 23 and 3 here. So basically 23 plus 23 is 46 plus 3 49 plus 3 52 plus 5 57. So add all of this. That is 23 plus 3 plus 5. That is the number of 50-cent coins plus 23 plus 3. That is the number of 27 coins, and that is equal to 46, 49, 52, 57. So that becomes, 57 coins. So that is the answer here. So the answer here is the number of coins is 57. This is more like using algebra. I've tried to use diagrams here, bar models here to represent them, but I could have simply used X as part of algebra also. If you replace these boxes with X, then it becomes an algebra solution. In the figure, a square, a right-angled triangle, and a circle with center O overlap one another. The ratio of the area of the square to the area of the circle to the area of the triangle is 10 is to 8 is to 7. Find the ratio of the shaded area of the figure to the unshaded area of the figure. Give your answer in the simplest form. So first thing to note here is this is the center. Remember that that is the key thing that we have to take note here. Let me change to the red color. So this is the center, which is very important. Reason why is that is if this is the center and the square is coming up here, then this becomes a quarter circle. This region that you see here, this is a quarter circle. This is the unshaded portion. And what you have here is a semicircle. So in fact, you have 3/4 of the circle that is unshaded here. Now the total area of the square is 10 and the circle is 8 and the area of the triangle is 7. Everything about the circle is key in understanding this. For example, what is the shaded portion of or before we go there, the circle has 8 units. So, or 8 is the ratio, or 8 units is the ratio, right? Now, this circle can be divided into how many parts? 4 parts, actually. I mean, if you divide into 4 parts, then you know that there are 4 parts, and each you can give a weightage of 2 because 4 times 2 gives 8. In other way of looking at it is you can divide it into 8 parts. So let's say I divide it here. I've got 2 parts, 2 equal parts here. This is a quarter circle. I divide it into 2 here and 2 here. This is already divided into two equal parts. So totally 1, 2, 3, 4, 5, 6, 7, 8. I have 8 parts which is represented here. Now out of this square, because when I say 7 is to 8 is to 10, remember, it is equivalent to saying 7 units, equal sized units. 1, 2, 3, 4, 5, 6, 7. And the other one is 8 units here. This is for the circle, this is for the triangle, and this is for the square, which again would be going up to 10 parts here. But they are all equal sized ones, right? With that information, now we say if the area of the square is 10 units, out of which 2 of the circle units are unshaded. So which means you just have to remove these 2, right? 2 of these units are gone. So for the square, the shaded portion is out of 10, 2 is gone. So 8 units is the shaded portion. Now for the circle, the shaded portion is very clearly shown, 2 units. For the circle, the shaded portion is 2 units only. So the rest is gone. And for the triangle, out of the 7 units that you have for the triangle, I have removed 1, 2, 3, 4 units here. So 7 minus 4 is 3 units. So for the shaded portion, for the square, we have 10 minus 2, that is 8 units. For the circle, we have the total of 8, actually, out of which 2 are shaded. So this is 2 units. And for the triangle, out of 7, we see 1, 2, 3, 4 of them are unshaded, which means 7 minus 4, the shaded portion is 3 units. So total shaded area that is equal to 8, 10, 13 units. The question is asking about the ratio of the shaded figure to the unshaded figure. So the unshaded figure, you can clearly see here 1, 2, 3, 4, 5, 6. So basically shaded is 13 is to unshaded is 1, 2, 3, 4, 5, 6. So the answer is 13 is to 6. And it says, given that the unshaded area of the figure is 86.4 cm square, find the area of the triangle. The unshaded is 6 units. So 6 units is equal to 86.4 cm square. So 1 unit is going to be 86.4 divided by 6. And the area of the triangle, as we saw here, is the total area was given to be 7 units. So 7 units would be 86.4 divided by 6 times 7. Let's see what is 86.4 divided by 6. 6 1 6, 2 6, 6 4 is 24, 2. You need to bring one more 4, but you have to dot here, so you put a dot here, 4, 6 4 is 24. So 614.4 times 7. Let's say 14.4 times 7. 4 7 is 28, 2, 28, or 9, 30, 3, 7, 1, 7, 10, and 100.8. Because there's one dot, one digit after the dot here, or in here altogether. So I'll have to put a dot after one digit here. So the answer is 100.8 cm square. So the figure is made up of two identical parallelograms, AB CD and CFGH. Angle ABD is twice the size of angle DBC. So this is 2 times this angle here. So if this was x, for example, this would be 2 times, so it will be 2x. Find angle BDC. So we want to find this angle here. We know that in any parallelograms, the opposite angles are equal, angles at the opposite edges, because if you look at it, a parallelogram, it's made of like these two are parallel lines, right? And these two are also parallel lines. This is parallel to this line here, which actually means that this angle plus this angle will be equal to 180 degrees, and this angle is equal to this angle. These are corresponding angles. But if you tilt this and look at it, this is also considered a transversal line, and this angle, these two are parallel lines, so this is a transversal line there. So this angle and this angle, how are they related? They are interior alternate angles, and they are equal as well. So this is equal to this is equal to this. By that principle, these two angles will be equal. So take the same here in this parallelogram ABCD. This angle is equal to here, which is 54 degrees. Now, the second thing to note here is that in any quadrilateral four-sided figure, the sum of all these angles is equal to 360 degrees. So we know that this is 54, this is 54. And we also know these things. This angle and this angle, they are equal. That is another thing to note. And second thing is, since these two lines are parallel, see this is parallel, this can be considered a transversal line here, which means that if this is x, this is interior alternate angle. So this is x, this will be x, and this will be 2 times x. All right. So now let's come back here. So this is 54 plus 54, which is 108. So this sum is 108. Then what will be these two together? These two together, because that is 360 minus, that is the total sum of all these angles, minus 54 plus 54, which is 108. So how much is 360 minus 108? So that becomes 2, 5, and then 252 degrees. 252 degrees is equal to sum of this and this. But you look at it, this is in the ratio 1:2, and this is also should be in the ratio 1:2. So you can either put it as draw models, or put it as x, represent them with algebraic variables. So 2x plus x is 3x, plus again 3x, totally 6x here. So 6 times x is equal to 252. So what is x here? This is 252 divided by 6. So that is equal to 6 4's 24. So 1262. So that will be 42 degrees. So x is 42 degrees. But they asked us to find BDC. So BDC here, to change the color to show the importance here, we want to find out BDC, this and up to here. So we want to find out this angle, and we have already established that this angle is equal to 2x. So x is equal to 42, so 2x will be 2 times 42, which is 84 degrees. So the answer should be 84 degrees here. And then the second one is find angle CDF. Let me see, CDF. So this angle is what we want to find out. Now take a look at ABCD and CFGH. It is mentioned that these two are identical parallelograms, which means that the corresponding angles should be equal because they are identical. Which are the corresponding angles? That's what we need to find out first. Now we know that these two angles, they are acute angles, they are equal. Where is the acute angle here? This is the acute angle because this becomes an obtuse angle. So this will be equal to this guys here. And this angle will be equal to 54 degrees or this 54 degrees, whichever. This is 54 degrees. So by that comparison of the two parallelograms, we find out this to be 54 degrees. So this whole angle in this triangle DCF, this whole is 60 plus 54. 60 plus 54. That is equal to 114 degrees. So this is 114. And in this triangle, let's see what kind of triangle is this, DCF. Take a look at this. Because this side is corresponding to this side, remember one more property of the parallelogram. Opposite sides are parallel and they are also equal. So this side here is corresponding to this side, which means this side and this side is equal. But this side AB is also equal to CD. So this and this side are equal, which tells us that this triangle DCF is an isosceles triangle. And we know that in an isosceles triangle, these two angles are equal. Now, in a triangle, the total sum of all the triangles is 180 degrees. So if I want to find the sum of these two triangles, it is 180 minus 114. So which is 80 minus 14. So that is 66 degrees. And we know that these two angles together equal to 66 degrees. And one of these angle will be 66 degrees divided by 2, which is 33 degrees. So this angle CDF is equal to 33 degrees. The following pie charts show the sales of 4 different flavors of ice creams in two shops, Shop A and Shop B. Each of the statements below is either true, false, or not possible to tell from the information given. For each statement, put a tick to indicate your answer. Shop B sold more orange flavored ice creams than Shop A. So lemon, oh, is this orange? Orange flavored ice creams is this much shown in Shop B, and this is in Shop A. Now, when you look at it, this looks like a bigger pie here compared to Shop A. But is it really bigger? That depends on, for example, Shop A sold 1,000 ice creams, whereas Shop B in total sold 500 ice creams only. Then what would this represent here? Will this be more than this, guys? Say, for example, this is quarter of these will be 1,000 divided by 4, which is 250, right? This is lemon is 250 here. Whereas here, a quarter of this would just be, how much is 500 divided by 4? 125. So a quarter of this is 125 and plus some more could only be 150 maybe. I'm just trying to come up with a rough number here. So here you got 250. 1,000 divided by 4 is 250. This was 250. But this one is just like 125 and plus you add some more also, it will come to 150. It's not going to come to twice because if it has to be twice, it would be something like this here, right? So only when I come the entire half semicircle, then that will be equal to 250 here. But this here is 250 just for a quarter. So it also depends on how many ice cream shop A sold and how many ice creams shop B sold. If we do not know that number, then this doesn't make sense. We cannot just compare these two. The only way when we compare this is the number of ice creams sold in shop A and the number of ice creams sold in shop B. If they are equal, then we can use the size of the pie to find out who sold more. If both of them sold 1,000 each, then I can say that for the orange itself, let's say for this orange, this is smaller angle compared to this by looking at it. And I can say shop B sold more orange flavored ice creams than shop A. But this information is not given. A could have sold more than B, or B could have sold more than A. So without that information, I cannot say if this is true or not. I hope that is clear. The second part, given that both shops sold the same number of lemon flavored ice creams. So this is lemon flavored ice creams and this is here. If they both sold the same number of ice creams, then shop A sold more ice creams in total compared to shop B. So what it means is this. Let me take this as an example. Let's say this is 100, okay? Shop A, this sold 100. And this here, the bigger pie represents 100 also. In this case, what is the total number of ice creams sold in shop A? How many quarter circles are there? One, there's another one here, two, three, and four. So the total should be 400 for shop A. But this is not just quarter, this is more than that. Let's say if this is my quarter is here, this is like 1.5 times a quarter. So if this whole thing is 100, then another 1.5 times would come up to here. So this is a quarter plus and a half. This whole thing would be 100. And this is definitely less than 100 because I need this plus another quarter to be 100. So this will be less than 100. So even then I get only like 200 plus here, whereas it is 400. So then this is true. Given that shop A sold 40 lemon flavored ice creams, shop A sold a total of 120 ice creams. So let's go back here. This is now no longer say 100. We just took an arbitrary number. Let's say if this was 40 for shop A, this is 40, then in total shop A sold a total of 120 ice creams. Is that correct? One quarter circle represents 40 and there are four quarter circles here, isn't it? So 40, 40, 40, 40. So 4 times 40 will be 160 and not 120. So this is false, right? So this is, sorry, this should be the tick one here. I had to put the tick here. This is false, yeah. Given that shop A sold 8 more mint flavor ice creams than shop B. So whatever you had, the mint flavor ice creams, it's 8 more than what you had in 6. So 16 plus 8, which is 24. So this is actually 24 now. All right. So the ratio of the number of mint flavored ice creams sold to the number of Nutella flavored ice creams sold is 2 is to 9. Basically 24 is to 36. So simplify this. 6 fours 24, 6 6 36. Again simplify this. 2 times 2 and 2 times 3. So it should be 2 is to 3 and not 2 is to 9. So this is false as well. Bowls are arranged neatly into 20 stacks of the same height on a shelf in a restaurant. The number of bowls in each stack is the same, and the height of each stack of bowls is 21 centimeters. An example of how 8 bowls pile up to form one stack is shown here. Now, how many bowls were there on the shelf? So there are 20 stacks, right? This is one stack. There are 20 stacks. And in one stack, it is said that there are 8 bowls. So there are 8 and there are 20 such stacks here, 20 stacks. So one stack has 8 bowls, 20 stacks, so totally 8 times 20, 160 bowls should be there. Three bowls from each stack were removed to form another 12 stacks. The row height of each stack is now 15 centimeters tall. What was the height of each bowl? So let's say you take 3 from each of them. So how many did we take? 3 times 20. So 60 bowls were taken and then stacked up. So in each stack now, out of 8, this is 8. Out of that, you take 3. So each now, the new stack would only have up to here, right? So that is made of 5 bowls. The new stack is made of 5 bowls and the height is this much. And they're saying that each stack is 15 centimeters tall. So this new stack is 15 centimeters tall. And the old stack was 21 centimeters tall. Now, if you subtract this, the old height of old stock minus the height of new stock, what all will get cancelled? Just imagine that I've drawn something like this here, right? Something like this. So that stack will look something like this, and the bottom will have something like this, all right? So the stack is going to look something like this, but it's made of 5 bowls, and this is made of 5 bowls. Bowls are neatly arranged into 20 stacks of the same height on a shelf in a restaurant. So this is shown as one stack. There are 20 such stacks. The number of bowls in each stack is the same, and the height of each stack of bowl is 21 centimeters as shown here. An example of how 8 bowls pile up to form one stack is shown here. So how many bowls were there on the shelf? In one stack, there are 8 bowls, and they say that there are 20 such stacks. So the number of bowls should be 8 in one stack times the number of stacks, which is 20. So it should be 160. And then 3 bowls from each stack were removed to form another 12 new stacks. The new height of each stack is now 15 centimeters tall. What was the height of each bowl? So what happens here, I've taken this 3, all right, and then I form a new stack where it was going to be something, the height is going to be like this because I'm taking up these 3, all right? So I would have, again, how many bowls? 1, 2, 3, 4, 5. So something like this. Let me first start with this base. It's going to look something like this, and I would have 1, 2, 3, 4, 5. I have 5 bowls here, and this height, new height, with just this ball, 1, 2, 3, 4. Sorry, there should be just this 5. So this is 15 centimeters. Now, if I subtract this height from this height, which is 21 minus 15, which is 6 centimeters. So 21 minus 15, 21 minus 15 is equal to 6 centimeters. And what is the height that I'm getting here is, see, if this visually, this bowl height gets cancelled. And after this, there will be four more such ones. One, two, three, four here. These four will get cancelled and everything gets cancelled, right? So I'm left with the height of three of these. That is the top portions of three of the bowls. One, two, three, sorry, four of the bowls. Oh, sorry, I'm doing this wrong. Three of the bowls here. The height of three of these bowls is what will be left with, because I'm cancelling out five bowls height, which includes the base bowl with the entire height. So now these three regions, right, that is equal to 6 centimeter. 21 minus 5, this is equal to 6 here. These three of them equal to 6. So how much is this one here? One portion here. So 6 divided by 3. It's like units here. You should think of this visually if you want to think. Let's say the height is going to be the base bowl plus 1, 2, 3, 4, 5, 6, 7. This is for this guy. This whole thing is equal to 21. For the second one, the base bowl's height is given here. Plus, you will have 1, 2, 3, 4. When you subtract these two, up to here, these get cancelled off. So what you're left with is the height of these three portions, these three units. So 3 units here is equal to 6 centimeter, because this whole thing is represented by 21 and this whole thing is given by 15. So 21 minus 15 is equal to 6. So that is represented by these 3 units here. 3 units is 6. So 1 unit is 6 divided by 3, which is 2 centimeters. So now take a look at this itself here. This, how many of these types of heights are shown here? 1, 2, 3, 4. And each of them is 2 centimeters. So 4 times 2, 8 centimeters. So from up to here, it's 8. And the total here up to here is 15. So what is this height of one bowl? Then the total height of one bowl, that is 15 minus 8. So 15 minus 8. So that is 7 centimeter. So 7 centimeter is the height of one bowl. A shop produces square tiles in two designs as shown below. Each tile is made up of 4 square tiles. The length of the side of each tile is 20 centimeters. Find the perimeter of the shaded part of tile B. The perimeter of the shaded part for type B, the perimeter is involving this, 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 and this. Now if you look at it, this is a square. Now, what is the length of this square? This whole thing is 20. From here up to here is 10. And this is a quadrant or a quarter circle here. This quarter circle, there is one more quarter circle here, another one, and another one. So 4 quarter circles of the same radius. That is becomes one circle. It becomes one circle, and the radius of this circle is 10. Now, what is the perimeter of this circle? That will be the perimeter of the shaded portion here. So the perimeter of the circle is 2 pi. They're asking us to take pi to be is 2 pi r, and they've asked us to take the pi to be 3.14, and radius is 10. So 10 times 3.14 will become 31.4, and that times 2 will become 62.8 centimeters. So that is the perimeter of the shaded point, which is 62.8 centimeters. Some tiles were laid out on a surface measuring 180 centimeter by 140 centimeter in an alternating manner. An example is shown below. What is the smallest possible shaded area of all the tiles? Now, first thing is each of this is 20. From here to here, this length alone is 20. And like this, you have many of them, and that covers 180 centimeters. First, we need to figure out how many such squares can be there. So in 180, you divide 180 by 20. First thing, you always remember the ending zeros that can be cancelled. So 2 times 9 will give you 18. So 180 divided by 20 is equal to 9. So you have 9 squares like these here. Similarly, how many squares can be here? Again, 140 divided by 20, which is the same as 14 divided by 2. So that will be 7. So you have 7 squares like this here. That is one thing to note. Second thing is that, see, out of these 9 squares, let me say take these ones here. I'm going to just divide this into 1 square plus 8 squares. I'll tell you why I want to do that here. There's 1 square here, and then there are 8 more squares. Now, if you look at it, the next square here will be identical to this, because alternatingly, the next square will be like this, and this will be shaded. And like this is, let's say I take this as one pair made of 2, and totally I have 8. So I will have 4 pairs here, not including the first one. I have 4 pairs here. That is this plus this 2, again another 2, another 2, and another 2. Total 8 of them. Now, why do I want to do that is, if I want, rather than trying to figure out what is the shaded portion here, what I can do is I can actually take this and put it down here. If I'm able to just cut this portion and put it in here, cover up this, there won't be any shaded portion in here, but here everything will be shaded. And the area of this square is actually 20 times 20, which is 400. And how many such pieces would be here? There would be 4 such completely covered squares here. So the area would be 4 times 400 for the first row alone. Now let's take a look at, I will have how many such rows here? I have 7 such rows here. Each row I have 4, and I have 7 such rows here. So the total number of such kind of squares, I'm not including this column, just this one, right? So that would be 7 times 4, 28 squares, and each has an area of 400. So the total area would be 28 times 400. I don't have to do the multiplication now. I can just first wait and figure out how many completely filled squares will I get. So right now, not including this column, just like this here, if I go on up to, let's say, 7 rows here, so I will have 7 rows. In each row, I have 4 completely covered squares. 4 times 7, 28 squares I've got so far. And here again, if it is 7, I have 1 square here, and then I have from here to here, I have 6 squares. 1 plus 6 gives me 7. I'm not including this. But this 6, because it's an even number, you say I can have this kind of a square and something which looks like this again here, right? So this would be like where this portion is covered. And again, if I take this and put it in here, this is totally unshaded, whereas this becomes a shaded square. So like this, I have 2 of them form a pair. In 6, 6 divided by 2 will give me 3. So they will have 3 such pairs. So I have 3 fully covered squares. So 28 plus 3. So I have 27 fully covered squares. The area of those 27 squares is 27 times 400. So that is 0, 0 as it is. 4 sevens 28, 8, 2, 4 twos 8, 9, 10. So 10,800 squares. Sorry, centimeters square. That is the area formed by all these squares. What is left? I've covered all the squares here. I've covered all the squares here. So what is left is just this portion. And to find out this particular portion, just consider this guy here. You can either do that, or you can take this whole thing, take it as a pattern here. This is made of a quarter circle, quarter circle, quarter circle, and quarter circle. 4 quarter circles make one circle. So if you're talking about a square whose side is 20 centimeters, and if I were able to flip this, this would form a complete circle here. So basically, this shaded portion is actually this portion here. So if I find the area of the square, which is 20 times 20, which is 400, minus area of the circle, which is what we saw earlier, not that's the perimeter, sorry. The area of the circle will be pi r squared. So pi, which is 3.14 times, radius is 10, 10 times 10. So that is 400 minus 314, which is actually 86 cm square. So here we had 10,800 and you have 86. So when you add these two, that gives the total area of all the squares. There is 10,800 plus 86 will be 10,886 cm square. A shop produces square tiles in two designs as shown below. Each tile is made up of 4 quarter circles. This is a quarter circle, this is one here, one and one here. Similarly, this is also made of 4 quarter circles. The length of the side of each tile is 20 centimeters, so this is 20 centimeters. Take pi is equal to 3.14. Find the perimeter of the shaded part of tile B for this one. The perimeter means I have to find the length of this here, length here, and the length here. So then if I want to find out this length, basically this is a perimeter of a quarter circle. Now I can do that and then times 4 because there are 4 identical quarter circles. The other option is if this is a quarter circle, this is another quarter circle, another quarter circle, and another quarter circle. And if I'm going to rearrange this, it would look something like this. The square remains the same, but if I just rotate this, this can become like this if you look at it. If I just rotate this, this will look like this, and where this will become the shaded portion here. And it will become a circle like this. Try to visualize this. So then this perimeter is nothing but the perimeter of the one entire circle here. So perimeter for a circle, the formula is 2 pi r. So that is 2 times pi. They've asked us to take it is 3.14 times. Radius again is here. This is the radius of the quarter circle, which will be the same, the radius of the circle also. That is 20 divided by 2, which is 10 here. So 10, then 2 times 3.14 times 10 becomes 31.4, because you just, when you're multiplying with 10, which has 1 0, move the dot 1 to the right. So that becomes 31.4, and 2 times this will be 62.8 cm square. Sorry, cm, not cm square. It's the perimeter, so it will be 62.8 cm. Now, some tiles were laid out on a surface measuring 180 centimeters by 140 centimeters in an alternating manner. An example is shown below. Alternating manner means you have this tile here, then you have this tile, then you will have this tile here. So let me just go ahead and draw that also, because that will be useful for us in understanding this visually. This is shaded portion. Now here also you will have the next one has to be something like this. This, and again this pattern should be here. Now we know that this length here is 20. We have 20, 20, 20, and the total length is 180. So how many such squares would be there? To find that out, we have to divide 180 by 20. 0 gets cancelled. 2 times 9 gives me 18. So there would be 9 such squares here. Here, how many squares would be there? So 140 divided by 20 again, because here also this length of one of the squares is 20. Again, this is 20, 20. How many 20s are there in 140? So 7. So you'll have 7 such squares here. Now, one thing to note is, take a look at this particular square. If I take the shaded area and then place it on top of this unshaded area, what will happen? This entire square will be shaded. This entire square will become unshaded. So I have a clear one shaded square and one unshaded square. Now, for every two of these, I can have one shaded and one unshaded square. Now the question is about finding what is the smallest possible shaded area of all the tiles. So we want to find the total shaded area. So what I have found out is, if there are two squares, if I just place it here, I have one shaded and one unshaded square. So for every two squares here, I will have one shaded square. So now the total was 9 here. I'm going to split it into one square here and 8 squares here, because 8 is an even number. For every two squares, I can get one shaded square. And in 8, how many such pairs would be there? There will be 4 such pairs, because 8 divided by 2 gives me 4. There are 4 such pairs like this. Then I will have one more pair like this, one more, and then one more pair. So I have 1, 2, 3, 4 pairs. And out of 4 pairs, how many shaded squares will I get? I will get 4 shaded squares. Now, how many such rows can be here? Because the total was 7. As we said, we have 7 squares here like this, which means in one row I have 4 of them. I will have 7 of them like this, which will cover this entire region, all of these together. So if I cover, then in one row I have 4 squares. I have 7 such rows. 4 times 7, so I have 28 shaded squares so far. Now let's go a bit down and see what we can do here. Now this is left out, right? I've not included this, any of these here. But again, if I want to look at this here, there's 7 of these squares. But let me leave this alone and then take here. All right. So I will have 6 squares here. Again, 6 means I will have 3 pairs. I will have this like this, one pair, and then I'll have one more pair, and then I will have one more pair here. And that means for these two, or for this pair, I will have, like, say, do the same here. Take this, put down here. I make one completely shaded square and one completely unshaded square. So for every pair here also, I will have one shaded square. I have 3 pairs, which means I have 3 shaded squares here. Now go back here. I had 28 shaded squares. Now I have 3 shaded squares here. In total, I have 28 plus 3 equals 31 shaded squares. Now what alone is left? This piece is left. I have not touched this square. We'll come back to that later. But for this 31 shaded squares, what is the area of one square? I mean the completely shaded square. As we saw, the length of this is 20, so this is also 20. And if this is completely shaded, the area of the one shaded square is 20 times 20, which is 400. And I have 31 shaded squares. So this 31 times 400, because 20 times 20 gives me 400. That is centimeters square. So this is 31 squares. Such squares are there. So 31 times 400, that gives me 12,400 centimeters square. So that is the total shaded area of 31 shaded squares, except that I'm just left with one over here. Now, if I can find the area of this shaded square, shaded portion here, and add to this, I get the answer. Now, how do I find this? There are again two ways. One is to look at this as a quadrant here. All right, you can, if you take this as a square, it is made of a quadrant and a square. So I take the area of the square minus the quadrant, I get this shaded region, and then times 4, I will get this entire area of the shaded region. But another option is just like how we did for this, just rotate this or move this so that, again, if you look at it, this is one quadrant or quarter circle. This is another quarter circle, another quarter circle, another quarter circle. So take this whole square, which is made of 20 by 20, and inside that I have one entire circle because all these quarter circles have the same radius. So I will have, consider this as one circle. Now this is the shaded region. They will come here. So if I want to find out the shaded region, I find the area of the square, and from that I subtract the area of the circle. What is left is the area of the shaded region. So I can do that also. Now if I do that, this will become area of the square is 400 minus area of the circle is pi r squared. So pi is, we are asked to take it as 3.14 times r square, radius times radius. And we know that the radius for this is 10. So it is 10 times 10. So this is 400 minus 3.14 times 100. And remember, because there are two zeros here, I will have to move the decimal 2 digits to the right. 1, 2. So this will become 400 minus 314. And that is equal to 86 centimeters square. Now this is the area of this shaded portion that you have here. That is the only thing that was not included in our total area of the shaded region, which came up to this. So now I will have to add 12,400 plus 86. That gives me 12,486 centimeters square. So the answer is 12,486 centimeters square. This is another question which will also require some visualization and revising some basic concepts that we should be aware of. The figure is made up of two rectangles, ABFG. So this is one rectangle, and BCEF is another rectangle. HXF and BDX are triangles. The perimeter of the rectangle ACEG is 90 centimeters. That is length AC plus CE plus EG plus AG or GA. That is equal to 90 centimeters. The ratio of AG, this is to AC. So AG is to AC. That is 4 is to 5. So which means this is 4 units, this is 5 units. So this can be written as 4 units and this is 5 units. But if you add all this, if this is 4 units, what do you think is CE? That is also 4 units. And what should be GE? Because that should be equal to AC, so this will be 5 units. Now when you add all these, 5 plus 5, 10, 10 plus 4, 14 plus 4, 18. So 18 units. I get 18 units. And the total length of all this is 90. So 18 units is equal to 90 centimeters. Now 1 unit is equal to 90 divided by 18. So 18 times 5 gives you 90. So that will be 5 centimeters. So 1 unit is 5 centimeters. So what does that mean? This length AG is 4 units. So this will be 4 times 5. So this is 4 times 5. That is equal to 20 centimeters. Yeah, the unit is centimeters. Here it's 5 units, so 5 times 5, 25 centimeters. So AC is 25 centimeters, AG is 20 centimeters. Now find the length of AG. AG, from according to this, we have found out is 20 centimeters. Find the area of the shaded part. Now to look at this, there is one more thing. X is the midpoint of BF. Now BF, you remember ABFG is a rectangle and this is the midpoint here. You know what is the, how do we find the area of ABFG? ABFG is GF times BF, or AB times AG, length times breadth. All right. So now what is, this is midpoint here, which means let's say I take this as, if I take this as B, breadth, and this as length, the area of this rectangle ABFG, that is equal to length times breadth. Now, what do you think is the area of this triangle FHX? Now, this is the midpoint of BF, which means if this whole length, which is equal to L here, and this Fx will be L by 2, because this is the midpoint, so this is half the length of this, so this will be L by 2. And what is the height of this triangle? This is from this vertex. You have to draw a line perpendicular to the base. Extend the base and this, draw a line perpendicular to this. So then this is the height. And this height is going to be equal to B. So area of this triangle, that is, this is H, yeah, HXF. That area is going to be half times the base, which is L by 2, times height, which is B. So this, if you look at it, is 2 times 2 is 4. So this is 1 by 4 times length times breadth. So area of this triangle is length times breadth. The area of this triangle is 1/4 of the area of this triangle. Now we come back here again. Now, what is the area of this BCEF? Say area of BCEF, which is a rectangle. Again, let's assume this length is L here, right? And this, let's assume as something else because we have used B here. Let's assume this to be B1, for example, this length from here to here. Now for this triangle, it is half times, sorry, first let's look at the area of this triangle, sorry, this rectangle BCEF. Area of BCEF is length times breadth. So sorry, this, if you consider this as length, this is breadth, L times B1. Now area of triangle BDX, that is equal to half times this base here. What is this base? Again, this is the midpoint, which means this also has to be L by 2. This is L by 2, this is L by 2. So this is base is L by 2 times this height here is the same as this here. This is the height that should be here, but this will be equal to B1. So B1. So which looks like 1 by 4 times length and times B1. All right. Now again look at, compare it, area of BCEF and area of BDX. Area of BDX is 1/4 the area of BCEF, which again means if the area of the shaded portion in both the cases is 1/4 the area of the respective rectangles. So the total area of rectangle, the whole rectangle, this entire rectangle, this length here is 25, breadth here is 20, 25 times 20. So that is 500 cm squared. Now the area of the shaded portion, as we have seen, is 1/4 the area of the respective shaded portion. So that area of shaded portion is 1/4 the area of the rectangle itself. So 500 in this case. And that is equal to 125 cm squared. So there we end this section. Hope this was clear. And if you have any specific questions that you think could be explained in a more clear manner, or list down those specific questions in the comment section. I will try to come up with individualized videos for those questions. We can go in a more detailed manner, and also I will try to include more visuals so that it's easier to understand. So happy learning. Have a great day. Bye.